Good morning, ladies and gentlemen. Thank you for joining us for day 2 of workshop 2. There was a very important point raised by one of my naval colleagues yesterday. What is the roadmap for UDA in future? So I have a presentation ready, which I will, it's not scheduled today, but if there is a time, I will definitely. And I would also like to give you a larger journey of UDA globally. I mean, there are powers who have had a UDA journey earlier. It's probably the term which has come 15 years back, but it's only a Canadian naval officer who used this term UDA. But otherwise, it has been the MDA which has been talked about. And as I had mentioned yesterday in my presentation, after the 9/11 and the 26/11, it became a very regular feature in every strategic discourse. But UDA per se has not been used so much. And some of us believe that the MDA is really not very inclusive and comprehensive in terms of the UDA coverage. So today we have a very good panel discussion. We have a research and academia representation, we have an industry representation, and we have also a patent counselor representation. We were supposed to have Mr. Mandar Joshi, who's the CEO of the Incubation Center in Pune, the Bhau Institute, I think one of the most important incubation. Unfortunately, he's not able to join us for some reason. Mr. Neeraj Panchal is joining us online. So I will, and it will be chaired by none other than Admiral DSP Varma, sir, former Chief of Material in the Navy and also the Director General of the Nuclear Submarine Project. Sir has been instrumental in encouraging a lot of innovations, a lot of industries, a lot of startups for the program. So I think I will hand over to sir without much delay. And sir, I think we will continue to sit there, and I'll request the speakers to, because Neeraj will be making a presentation on the screen. So for ease of viewing his presentation, I think I'll request the speakers or panelists to continue to sit where they are, and they can come here. So, sir, I'll request Commodore Talwelkar, sir, please come on the stage, and Professor Vijay, please come on the stage. And Admiral, sir, kindly take over here.
Well, today's panel discussion is innovation in the startup ecosystem. Now, all of you know what's an innovation, basically. Anything can be innovation. It could be a product, it could be a process, right? Could be anything where you think differently, make something that is more, it could be totally new, or you could be only making a change to make it better, etc. And this has been happening, but there has been no, focus in innovation, because all of us, I'm sure, must have innovated something to make things better in our time, and could have built on it, but there was no ecosystem or thing to help us or push us towards the direction. But today, with the great demographic that we have and such bright people, I don't mean that we old people were not bright, but brighter people. Okay, it is important that we harness this spirit of innovation, right, and give the direction. I can give you a small journey. I myself started after I left the Navy, and my last job, that is around 60, at the age of 67. I also started a small startup. I mean, but for sure it would fail, and it failed. Not because we couldn't finish the product. The product was made, product was tested out by big companies. But then there was one thing I didn't cover. I didn't cover my back. So those guys who are working for me, they all obviously, I get a pension, they don't. So they get a salary or whatever it is, whatever the compensation or whatever you call it. And I had only one promoter, right, who was supposed to be giving the money. First year was okay. Second year, a promoter always looks for return on investment. So his return on investment is not coming. He says, I can put in FD and get more money than I'm getting from you chaps, etc. But then to develop something, to innovate and put something, and especially in the area of cybersecurity, it was a very good platform. Uh, I in fact, even from the uh, department of that innovation thing, which is in, I don't recollect now, DBT. I went and met the secretary. They were very clear. They gave me forms to fill up, etc. And of course, I gave it to the company to do it, because I'm only getting the people together. So-called mentor. I stopped calling myself mentor after I failed, because a mentor is supposed to take the system through. Um, but yes, I learned a lot, and I had to allow the people to go, because I was not going to ask them to continue on hope, you know. So it had to close down. But there was a product completed in 18 months flat. It had trials. We carried out on a platform. We put it. We had um, Tata uh, Tata Infotech to come and carry out the complete trials. They were very happy, and they were very ready to join us. But then I suddenly lost all the people, because they also learned on the product. They learned on the domain that was given to them. Now they had a product. They had a guy who's thinks so. They started on their own. That's how it figured out. But I won't blame them, because obviously, what keeps anybody is he has to look. He's a young man. He's looking at things. So there was a failure in the system. Now, to avoid such things, though of course it's the present what you call innovation thing, that Atal mission, etc. They say if you fail, it's a trial. We'll again give you an opportunity. But the Atal mission didn't exist. I was slightly ahead of time at that time. Nor was I registered anywhere. Now the system is done. The total system is different. There's a lot of help for uh, people who want to innovate, to get into the startup thing. There's an ecosystem that has been created. All of you know about it. I don't have to repeat it. You have, the Atal Innovation Mission, and I think it's important for you people to just go and have a look at the Atal Mission. It's quite good. I wish it was there. Unfortunately, it came in 2015 or 16, and my 2013 I started. In 2014 or maybe early 15 I had to end up thing. Yes, I lost some money, but not much of mine. More of the promoters, less of mine. So I got away, thing. But yes, there was a big lesson. That is, before you want to mentor somebody, please tell him what are the failures that are possible if you don't look out. The country also, in the last 8 9 years, has come up with a lot of things for which we can call up the ecosystem that has been set up. You've been hearing of Make in India. You've been hearing of so many hackathons happening. You've been happening the IDEX, where you can give your ideas, etc. So there are a lot happening. So today there is this what do you call environment for those who have ideas, to put their ideas across, or align their ideas to what people require, because sometimes like IDX, etc., they give you okay, anybody who can do XYZ, come up. So maybe you can do that, use your thing there. And yes, Startup India is another one. uh, Skill India, and that's why we are trying to get into that line, to Skill India for with respect to the underwater domain, and Stand Up India, and various things like that. So as I mentioned, you can have ideas. I mean, you will have ideas. Uh, you'll have inventions. I will call it an invention. Invention is wrong, but then you'll have an idea or an innovation in mind, and you probably will have researchers, right? Who, because some of them will have to be researched. Will have the researchers. You may also have, startups at various stages. Even they require an ecosystem to exist, even if you have managed to cross the first line, and somebody to put the money, right? And there's a first time, so they become entrepreneurs, right? You're doing something on your own. And the entrepreneurship in the country has really improved. Wherever I go, everyone is saying he's working, I think he's got 10 fellows and he's doing something, which is good. And as all of you know, today, I think number of startups and number of unicorns that India has, I think we are number 2 in the world. I don't know. Is it number 1, number 2? Okay, you don't know. I think we are the second largest number of startups, and I think second largest unicorns also. So that's quite good. It's not small, yeah? And it doesn't matter what number you have. The very idea that you have a unicorn, a chap who can make $1 million, million, right? Who somebody wants to invest 1 million uh, in your thing, 1 million or more, a unicorn, 1 million. Okay, so that means it's dollars. We're not talking rupees. Is good, right? So we call them. They can be called like angel investors. Some could be angel investors, right? That means they're just giving for the like the angels, no love of thing, and wait for the thing to come. And you require startup mentors because the process of going from an idea to innovation to startup, it has to follow some logical sequence to be able to reach the final aim, right? You can't be an inventor all your life if it doesn't become a product, doesn't go into the market. There's so much of legal issues which will come in, right? Uh, 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 I think the the next speaker uh, who will be talking on IP. Uh, Hello, sorry you're behind me, but then I'll get to you when you're speaking. So he'll tell you all about the IP, thing, because I understand he's an IP counsel, so he will tell you. Even I'll learn a little more on that. Uh, Advisors, lots of them. I'm one of them. So advisors are always there, but please have mentors. Advisors are many, right? And and you must have that mind for entrepreneurship. Anybody cannot become an entrepreneur. An entrepreneur is one who's ready for a failure, right? And doesn't sit on it after that. And with all these things come in today, it is possible, right? And I also know, this is my personal knowledge, a lot of NRIs are investing into this kind of startup ecosystem because I have my own, uh, you know, uh, I won't say friends, but acquaintances who are heavily investing in this and looking at it. Now, you require some organization also, right? Like, for example, you have the Bhau uh, Institute here. It's fantastic. They do incubation. They do, what do you call that? They have accelerators, startup accelerators, incubators, all of them they have. And they have also investors who, they put you face to face to get into that line, and probably some IP advisors. So there is an ecosystem, Bhau Institute, which has been created. It is in the College of Engineering, Pune, but I think it's a independent private. It's a non-government kind of a thing which was set up. Uh, we never heard of something called crowdfunding. Now, crowdfunding also can take place. A lot of people do crowdfunding, Um and as far as for disseminating your information, everybody has blogs, everybody has media, so all these things get help. So what I'm trying to tell you is basically there is today a culture for entrepreneurship. There is a platform for innovation, right? And there is a uh, what do you call organization to help you. That is an ecosystem that has been created. So this is the ideal time, and I'm glad. Uh, and one as I mentioned to you, that to do all this, right, in all thing, you might have an idea, but you require somebody to work with your idea. So you have to have people with the skills, right? So you have to start getting the skills also. Like this man talks about UDA. Everyone thinks UDA means UDA. Nahi, UDA nahi hai. It is underwater domain awareness. So you have to make them understand that what is underwater domain awareness. Everyone knows awareness. Everyone knows underwater. What is domain? Domain is everything there, right? So what happens there? How much is technology? How much is process? How much is data collection, right? What are the skills required? Can we skill them up, right? And create a ecosystem for them to innovate and think. That is the aim of UDA. So I suppose will come. Now, and especially for the underwater, considering the Sagar vision, you got a what do you call hand on top under the Sagar vision. You can get into Atal mission and then do a skill India, and we hope we can use that. I purposely brought you back to UDA because this is a UDA platform. So some of us shouldn't be wondering what am I going to do here. There is a lot of work there which can be done. Now I leave it to the experts because I'm one of those generalist fellows, speak more from experience rather than from thing. So I leave it to my colleagues here in the thing to continue. And before that, Arnab will take over the.
Request Talwelkar sir to kindly. Sir.
Good morning, everybody. Today is a pride moment for me to be here with you for the very simple reason. This institute is my alma mater. I passed from this college way back in June 83 from the mechanical faculty. After passing out from college, within a month, I joined Indian Navy. To be very precise, 31st July 1983. Landed up in Kochi. The Naval Academy was in Kochi at that time. And then for the next 35 years and 4 months, it was life in white uniform. Many of you will not be aware of what that life means. Lot of challenges, and despite being mechanical engineer, I had an opportunity to do my MTech in computer science from IIT Powai. In my entire 35 years and 4 months, my mechanical engineering association has been very minimal. I did project management, I did budget management, finance, HR, training, you name it under the sun, and the Navy provided me an opportunity to have an experience or an exposure to it. And that exposure is helping me in my second career in Bharat Forge. I retired from Navy in 2018, and then for the past 3 years, I'm with Bharat Forge. God has got a lot of designs for you. What you don't want to do, God makes sure that you do it in this life. I will cite 2 examples. When I did my MTech in computer science, I was offered MTech in vibrations. And I was very afraid with this concept that even these walls and the roofs, they have got natural frequency of vibration, and I couldn't imagine the roof vibrating. So I refused that opportunity. But then my last assignment in Navy, which was Director General Naval Trials and Acceptance Authority, I was heading a unit which was deep into vibration analysis and necessary corrective actions. Second example, in Navy, being a mechanical engineer, I had no exposure or no opportunity to deal with weapons. Today in Bharat Forge, I am deeply involved in indigenization of gun barrel and gun jacket. Okay, so moral of the story is do whatever you have to do early in life so that at the end you don't have to do it. Now coming to my presentation today. Innovation and startup ecosystem, underwater domain awareness, industry perspective. The heading is very large. Okay, but I was told that I have to focus more on the underwater domain awareness and also have to give a few of my thoughts on the ecosystem, startup ecosystem. That's why the heading is a little bigger. Next slide, please. I'll be covering my presentation under the following heads. Little bit of company introduction, the initiatives Bharat Forge has for skill generation and innovation. Then the products what Bharat Forge is dealing with related to underwater domain. Initiatives of Bharat Forge to support MSMEs, and then the wish list for sustainable ecosystem. Very brief company introduction. Bharat Forge was founded in 1966. Initially, till about 2020, it was a component manufacturer and a preferred supplier. Subsequently, the company realized that they have to get into the design, and then they became a design partner or a development partner. But then From 2012 onwards, a need was felt to get more into the design, and then subsequently the company, what is today, is an engineering technology solution provider, and it also expanded its product profile. It's the turnover is more than 3 billion US dollars, and it has presence across the globe, 16 locations in India, 5 in Europe, and 2 in America. The industries which Bharat Forge serves: automotive, commercial vehicles, private vehicles, oil and gas, power, railways, defense, agriculture, and aerospace. Some of the product profile related to defense are as shown: artillery guns, armored vehicles, protected vehicles, ammunition, small arms, and a few electronic items also. Coming to the marine, where I am particularly dealing with, the first what you see is the naval armament, SRGM gun, which I just mentioned, the underwater systems, torpedoes, AUVs. I will be touching this in more detail subsequently. Lithium-ion batteries for the strategic submarines and electromagnetic launch systems. And in the core marine engineering, we deal with propulsion system integration, shafting, steering gear, and certain varieties of pumps. Now coming to the skill generation, Bharat Forge has got a unique program where certain select personnel are sent for studies at the cost of company and while they are on the payroll of the company. A few of them are sent for undergraduate studies. Few of them are sent for postgraduate studies in both management as well as in technical subjects at IIT Powai as well as with BITS Pilani. And few of them are sent for postdoctoral programs. This trained manpower is utilized at something known as KCTI, Kalyani Center for Technology and Innovation. There are two of them. One is in Pune at Keshav Nagar, second is in Bangalore. And this KCTI is the heart of technology-driven strategy. The KCTI has got tie-up with a large number of reputed academic and institutions across the world. The facilities available at KCTI Pune include failure analysis, metallography. A large number of NABL accredited labs are there for various testing of material and validation studies. In-house design capability has been set up at KCTI, and we have a large number of softwares: Unigraphics, SolidWorks, CATIA, Abacus, etc. Finite element analysis, CFD analysis is also undertaken, and the result of we also have a very unique software called as Shaft Designer software. It doesn't do shaft design, but it does calculations related to shafting alignment, vibration analysis, and the bearing reactions. This is useful during the design stage as well as during maintenance stage. The result of KCTI's facility is shown on the slide. We have been able to develop the bitinetic steel for front axle beam. This has an impact of lightweighting and higher strength. There are 8 artillery guns which Bharat Forge has developed, and KCTI has contributed handsomely in that. The KCTI at Bangalore specializes in jet propulsion technology. So far, they have successfully validated and tested 40 kgf, 80 kgf, and 160 kgf thrust jet engines, and presently they are working for development of 400 kgf thrust engines. They undertake engine cycle analysis, design of compressor, turbine, rotor dynamic analysis, heat transfer analysis, and they also have a lab to test the engine what they have developed. KCTI is assisted by KCMI, Kalyani Center for Manufacturing and Innovation. And here, a large variety of sophisticated machine tools are available. Metal injection molding can be undertaken. We undertake 3D printing also, plastic as well as metal. Very sophisticated gear manufacturing facilities there. There are nanotechnology lab, RF lab, AI lab. Large number of facilities are available. One of the product what I like to mention here as far as the innovation is concerned is the in-house development of oxygen cylinder during the COVID pandemic. You will remember that during COVID, there was an acute shortage of oxygen cylinders for patients. And Bharat Forge undertook this task on itself. The entire development was done ab initio, and then huge, I think few lakhs of these oxygen cylinders were developed in a flat 3 months and delivered. Okay. The body is aluminum. Bharat Forge hardly deals with aluminum, but the complete design, development, proving, and supply happened in 3 months. This is the commitment. Now, coming to the products related to underwater domain, Bharat Forge is presently dealing with expendable underwater targets. This simulates submarine for torpedo firings and training. Having a submarine at sea is a very costly affair, and if we have something to emulate the presence of a submarine, that becomes much more simpler and easier. Similarly, we have a mobile target emulator. If we are firing a torpedo, you need a target, and for that, again, having a submarine is a costly affair. So if you have an active propelled decoy, you can use it very effectively. Then another area is autonomous underwater vehicle, particularly if we have to do magnetic signature mapping of a ship, we need to go to Goa. Okay. And again, there are limitations because in monsoon ships can't be deployed there. So there is a autonomous vehicle, which is underwater vehicle, and there are magnetic sensors provided. So the vehicle can go around the ship and do the magnetic signature measurement. Then certain torpedo upgradation has been undertaken by Bharat Forge for a variety of torpedoes, and the spares have been supplied. And Bharat Forge is also trying to do something with sonobuoys and seabed surveillance system. Now you are aware that sonobuoys are required because the typical domain what we have, underwater domain, the turbidity of water, temperature, and the profile, is very, very bad for sonar. We hardly get any ranges, and therefore to facilitate detection of underwater targets, we need to have sonobuoys, and that too in large number. And that is one area where Bharat Forge is trying to explore possibilities. The mobile target emulator, it looks like this. In addition to what Bharat Forge is doing, Bharat Forge is also trying to support some MSMEs. I will cite example of two MSMEs with Bharat Forge is dealing with. One is Aeron Systems Private Limited. It is a Pune-based system, Pune-based company. They specialize in embedded systems, and they are developing inertial navigation systems. Now you will appreciate that it is not possible for any company to have vertical specialization in many, many fields. It's a very costly affair. So best is tap the resources from outside so that, the collaborative environment, both parties can win. Similarly, we have a tie-up with Cognite Bangalore for development of language translators. This is particularly useful for my army colleague, and he happens to be from infantry, so probably he will understand the importance of it more. Okay, and field trials are presently going on. Okay, now coming to the most important part of the presentation. Although it is just one single slide, I can spend hours and hours on this, but I will take only a few minutes. The first part is the funded R&D. This is the wish list of a company. And what I mean by funded R&D, I'll again cite the example of Bharat Forge. Bharat Forge has developed 8 variants of artillery guns for Indian Army. This development has taken 10 to 12 years. And this complete development has happened ab initio, suo moto, on so-called NCNC, no cost, no commitment basis. Not a paisa has been funded by either government or any other agency. Okay, how many companies can afford this kind of R&D? Very few. Okay, so this is one area where, I don't find too much of thrust the companies are giving for R&D. But if the R&D gets funded, we do not have scarcity of talent. There is enough talent. Only thing what we need is some helping hand and some backup. So funded R&D is something which the policy makers must take this point home. Second is willingness to accept failures in development. No development will happen without failures. It is impossible, or rather impractical, to expect that I will develop certain things which is new one, and that to right in the first attempt. And unless we fail, you will not even learn. I'll just give one example. Sir, pardon me, it is okay. I will avoid the classified part of it. There was a missile to be fired from one of the strategic platform. Okay, the missile was fired and it went somewhere else. When the analysis was done, it was realized that the system was reset once or twice. Every resetting, there was a certain algorithm which oriented the missile to go in a different region. Had we not failed, this important lacuna couldn't have been recognized. And imagine the consequences of this when we were in actual, battlefield. Okay, so failures are a must, and therefore we must be ready to accept failures for the development process. Every failure has got cost and time implications, and we need to be patient to see that we are able to move ahead despite failures. Now, another important one, new technologies and not merely tail chasing. Okay, there are dare to dream projects, etc. I'm not, criticizing them. They are required. But are we really looking at absolute new technology? Some of the examples which I cite there are like, say, water jet engines. Now, water jet engines have been there for ages together. We are now trying to develop that technology. Okay, it's a good step because we did not have it, so we must have it now. But then that is not the end. We need something absolutely new. If you recollect, the internet is because of defense initiatives, the defense ARPA program in America. Okay, defense needs to be at the forefront of R&D. Unfortunately, in India, that is not so. There are many areas where we have a huge amount of work to be done. Underwater is a very important domain where huge amount of work is to be done. Okay, I have, in my last assignment, I was DG NATA, where I dealt with vibrations, underwater radiated noise, and mitigation technologies for it. I'll tell you few examples where we are lacking badly. You know, a fan, a propeller is a fan. Any fan you start, it makes noise. Propeller also makes noise. That noise gets transmitted in water and it can be picked up by the enemy sonar, and your position and your identity can be easily compromised. We are looking at a propeller which minimizes noise generation. Okay, we call it cavitation. And this cavitation happens at a certain speed. Okay, if this speed at which the cavitation occurs can be prolonged, that means instead of say 10 knots, if it happens at say 20 knots, 25 knots, the advantage would be that the speed of advance of ships can be effectively increased. That will increase the maneuverability and will also affect, or rather prevent, detection of ships at an early stage. We have made extensive progress in the field of missiles, in the field of nuclear, okay, space. But I'm ashamed to say that India does not do propeller design. Okay, my colleague is here from, at least I'm not aware that whether we are doing any propeller design, and if we are doing it, then cavitation delay should be one of the major factors what we need to take into account. Second is the shock vibration mounts, the entire equipment design. Okay, we have got very good stealth platforms, but they remain on paper. The implementation is so poor that, there are simple things like noise shorts, cavitation, the noise passed through the pipes, ventilation systems. There are many areas where a good work can be done. NPOL has developed fantastic sonars, but then they have limited in a very closed domain. The remaining of the Navy has not got benefited. Okay, so we need to have this, the silos need to be broken, and such experts which are there from NPOL, who are retired scientists, need to be tapped. Industry is available to, undertake the work. If the government policies facilitate and funding is done, industry, government, and such academia can be a very potent combination to develop absolutely state-of-the-art technology. The last point, the commercial aspects for MSME. Varma sir explained in his opening speech that the efforts what he did, in this startup sector could not be successful, and one of the prime reason for that was the commercial viability of the project. Okay, Bharat Forge is presently dealing with 2 MSMEs. There is third one also, Black Straw. Okay, but at some point of time, these MSMEs will stand on their own feet. Okay, ultimately, this is a commercial relationship. So when they stand on their own feet, things may not be so easy for them. For many MSMEs, they may not be able to be lucky to have companies like Bharat Forge to support them. So their commercial viability needs to be ensured so that the talent doesn't go, is not wasted. Well, I must thank Arnab Das to give me this opportunity, because first is that I'm ex-COEP, and then secondly, able to air my views, which are so close to my heart. So thank you, Arnab. And I'm coming to the end of my presentation here. If there are any questions, I'll be happy to take on. I thought that I would be the last speaker because there are so many eminent speakers on the panel, but then I was again pleasantly surprised to be the first one to give my talk. Thanks a lot.
Thank you, sir. Commodore Talwelkar, sir, thank you so much for your very fine presentation. I'll request Dr. Vijay Kumar to please come and give his lecture.
Very good morning. Am I audible? I will, as a part of introduction. So, I joined Navy along with Arnab. We are NEC 7 engineers, naval architect, turned to naval architect. I did my BTech from naval architecture and shipbuilding from Cochin University of Science and Technology. Did my postgraduate diploma from IIT Delhi, a 2 years course. Then, of course, as a part of the service only. Then did my IIT Madras MTech in the ocean engineering. That was a little bit of turning point. Till then, I was more inclined towards management and management side. Some insight into the research activity has triggered me there. We did a project that was a vessel which was built in a country abroad. They were trying to plane. The vessel was just ditching. It was not even able to plane. So that was a case, and it came as a surprise to them. They made a model, took it to our ocean engineering department. I was doing my MTech. I took up that as a, my guide was able to give me that as a project, and we did it. Within 10 days, we could solve the issue. And that was one. Second project, what came was that is that they built a lubrication oil tanker. The tanker was supposed to go and deliver the oil to the vessels which is there in the oceans, which are at the anchorage. And it was designed to go 10 knot speed. And after 4 knots, the vessel tried to reach more than the 4 knots, it starts vibrating at the aft. So they could never go more than 4 knots. Then happened is the current at that place is 4 knots. They were all panicking. Again, it came to IIT Madras to solve the issue. Professor Ananda Subramaniam was there. I was doing the MTech. I take it as a MTech thesis project and did a thorough analysis that gives small mistakes what we make in the design lead to a bigger problem later on, and which we try to ignore at the start of the point also create a problem. So this too has initiated me into dwell upon into research. And as a part of the course, I did my PhD from IIT Delhi. That is also Navy related work, and completed that, continued in the service, and after 21 years took a VR, then joined IIT Madras as a faculty. Now I am associate professor in the ocean engineering department. This is my small journey, the last 20 or 27 years into the both in Navy as well as in the academics. Being a pure academician, I want to innovate and give a lectures. So my first introduction is to look at it academically and look at it what all the successful startups which are there recently, which has developed and which we are all using it, and what is the startup ecosystem in IIT Madras. These are the 3 headings I will able to analyze. The first one was to list down what all the areas in which where we can start up in the underwater domain. So I have listed down, I have made a list of 13 number of cases. I'm going to read it. Please have a patience to listen to me. I have got a presentations, but that is for the second sessions where I'm going to talk about underwater robotics, and I will also deal with what all the work I do. So the potential startup area as academicians, I listed on 30 in number of areas, which covers almost all the domain, being most of your students who want to look into the underwater domain and what all the areas, I will list it down. The first one is marine energy storage solutions for offshore renewable energy sources. We have offshore renewable sources, able to place it somewhere, but you have to transmit. Can I able to store and then able to get it back? That is one area. Second, autonomous underwater vehicle for inspection, maintenance, and research tasks. Already, there are certain successful startups which are available, but you can look at it. Third, marine robotics for various applications, including search and rescue, underwater mapping, and surveillance. Fourth, sustainable marine coating to reduce environmental impact of marine transportation. Fifth, ocean monitoring system to track oceanic parameters such as temperature, pressure, and salinity. I will be talking about gliders in the next next presentations. Sixth, marine traffic management system to manage marine traffic in busy ports and shipping lanes. We also have certain systems which have been developed by IIT Madras for this. Anti-fouling technologies to prevent the buildup of marine organisms on the hull of the ships and the boats. Coastal protection technologies to protect coastal areas from erosions, flooding, and other environmental hazards. Ninth, marine waste management system to collect and dispose marine waste, including plastic waste and other water pollutants. 10. Marine aquaculture technology for sustainable seafood productions. I'll just touch upon this in my next presentation also. Then 11th, offshore drilling technologies to improve the safety and efficiency of offshore drilling operations. 12th, marine seismic technology for marine seismic survey and explorations. 13, marine communication system for ships, boats, and offshore installations. 14, marine materials that can withstand harsh marine environment, including maintenance cost and improving the lifespan of the marine structures. 15, marine data analytics tools and perform to analyze oceanic data and support decisions making in the maritime industry. 16, marine desalination system of seawater and brackish water. 17, underwater mapping and surveying technology for underwater environment. 18, marine cybersecurity solutions for maritime industry, including ships, ports, and offshore installations. 19, marine weather forecasting system for marine environment. 20, marine renewable energy storage solutions for offshore renewable energy sources. 21, marine pollution monitoring system to track pollutants in marine environment. 22, offshore aquaculture system for offshore seafood production. 23, marine biodiversity conservation technologies to protect and conserve marine biodiversity and ecosystem. 24, marine tourism technology to enhance the tourist experience in marine environment. 25, marine search and rescue technology for search and rescue operations in the maritime industry. 26, marine cargo logistics and track system to track and manage cargo logistics in the maritime industry. 27, marine geotechnical engineering solutions for marine structures and installation. 28, marine hydrodynamics for marine hydrodynamic analysis and design. 29, marine spatial planning system for marine spatial planning and management. Then 30, marine biomimicry of nature solutions. Certain propulsion devices also can be mimicking certain marine organisms where they have the maximum efficiency compared to the propulsion. It's 60 to 6, maximum 65% of efficiency which you can have. So you have got a huge growth there also. And there are certain projects which you are doing. We will discuss it in the later. So when Arnab gave me this task, I immediately went onto the internet and then searched what are all the latest startups which are successful startups. So 7 names have popped up. And those 7 names, some of who are working on the certain underwater domains, awareness, and the underwater robots building up, should approach them and got certain items from there and used it. So 7 names which came out from the net. Once I Googled it was So Far Ocean Technologies that develops and deploys autonomous ocean monitoring system, provide real-time ocean conditions, including temperature, currents, and the marine life. Blue Robotics, we also bought a lot of thrusters from them for making use in many of the ROVs. Then Aquabatics, Navatics, Open Ocean Robotics, and the last one was Planis Technologies. That really Planis. Planis, P-A-L-N-Y-S, Planis Technology. That is an ecosystem which developed from our ecosystem, IIT Madras, which the 2 MTech students started off, and then they have grown. and then grown big for the IIT system to manage, meaning they have been told to move out. So the IIT system worked, and then they are quite successful. And in fact, if you have invited them, they have been invited and they have been giving talks to many places. They started with the small robots. They do a lot of underwater inspections. They do inspection in the dams. They come out with many this one. So IIT Madras as a whole, it is to talk about them. I also picked it up. Some of the numbers may not be right, but it is a quite good numbers to talk about. So we have around in the this one, there are more than 200 or more than 300 startups which have been there. We have 4 startup incubations. This one centers initially started with this one incubating. The incubation center started with the Rural Technology and Business Incubator, then Healthcare Technology Innovation Center, then Bio Incubator, and the Research Park. The Research Park, the facility which is available is to see to believe it. Very fine buildings, got a very good amount of facility for incubating and having a startup to startup. So I was also gone there and seen, having an idea to have my own startup on certain research which I am doing it. So it does provides you a space, it provides you a seed funding, initial amount of funding, space in the sense where your people can work free of cost, and certain labs and certain rooms, well furnished rooms for conducting your meeting with others. They have a legal system to support you. They will do the market analysis of your product viability, whether it is going to survive or not, and they will mentor you through all your journey. Generally the startup starts with 1 or 2 persons. The IP protection they will get it, IP protection they will do it. Then when you grow, how to grow, where to market it, and that makes a lot of difference for the young boys. The main idea was to have it as, at least we have to generate certain amount of job and job opportunity, and it has been successful. One of the old numbers says that more than 300 to 400 startups have been come out over there. They have $135 million fundings combined over 1.4 billions are the earnings or something in that range. It is there. Certain successful one are develop into a bigger and bigger system, and then they transit out of IIT system. So some of them are Agnikul Cosmos, Fabed Automations, Detect Technology, Modular Housing, even 3D printed housings. All those things are available. Some other startups which are developed, and then they are able to venture into the market. See, the success rate of the startup incubated at IIT is also not very high. It's high, but not very high. I will not let out the numbers. I'm not sure about it. It depends on various factors. At what stage you are starting your startup, how the industry operate, and quality of your product, and what kind of service you can give to the product. All those things it depends upon. Of course, other factors like environmental, where you pitch in, and how you are getting the help from the ecosystem and all those things. See, in conclusion, I would like to say that the underwater technology presents an enormous opportunity for all the people, all innovators, and people who are want to discover new things, put up an idea and get up into a new products. It is because the domain is big and available opportunities are there. By working together from industry, academia, and the partnerships, this ecosystem can be successful and startup can be successful. With this, I would like to conclude my talk. Any questions and other things, you can have it. Thank you.
Thank you, Vijay. Your ability to always focus and come out with very critical inputs amazes me. Now, I'd like to invite Mr. Neeraj Panchal, my very good friend. Neeraj, kindly introduce yourself and then make your presentation. Thank you so much.
Thank you, Arnab. The topic which is very close to my heart when it comes to innovation and the startup ecosystem, where India is at the right spot currently. My name is Neeraj Panchal, and I'm intellectual property professional for last 22 years or so. Worked with different organizations with IP firms, but majorly I remain connected to the industry where I can actually contribute from the very beginning or conception of the ideas. Coming to the topic of today, where startup ecosystem and innovation have been talked about, I was listening to our earlier speakers and especially Mr. Varma, who mentioned very nicely the entire ecosystem. One thing I picked up from there is uh, the risk, the risk which is inherent part of any startup uh, or any business for that matter. So how do we cover that risk? How we can somehow be prepared to mitigate the risk? At the same time, I feel that failing is important. I've seen that in many inventions which could not make it to the commercial, as I deal with innovations or inventions on daily basis. So my personal belief is uh, efforts are important, and the direction is definitely important. The guidance, the advisory we get in the ecosystem, which, as I was mentioning, currently India is at a point where I think we have everything um, which is needed to take it forward. Looking at all the possible driving forces which we have, whether we call it Skill India, Startup India, Innovation India, those initiatives taken by the government, and then look at the intellectual property. And I'll briefly talk about what IP is for the benefit of everyone. And please excuse me if it is any repetition for anyone, but I'll be talking the details later during the later session. So, intellectual property is a creation of your mind. Uh, it has multiple facets. It protects the inventions. Uh, and inventions and innovations are two different things. Innovations uh, may not necessarily be inventions, but invention plus commercial aspect makes it innovation, where commercialization is possible. So inventions are part of the patent system where patents are granted, and patents are for limited period of time. Um, Across the globe, it is 20 years. A few myths or misconceptions some people have that there's a global patent or worldwide patent. There are no such things like worldwide or global patents. In whichever country you are interested in protecting your invention, you have to file the patent in that country. Um, there are some systems through which you can file globally or in multiple countries. And then at a later stage, when you have funding, when you have proof of concept, when you are confident enough, then you can accordingly expand the scope of your invention protection. It's a costly affair. In India, it is not. India is still very good in terms of supporting the innovation system, the patenting system, especially for the startups, for individuals, for individual inventors. So that's majorly all about patents. Then comes design, patents which are protecting the aesthetics of any product. Coming to the branding aspect, which is covered or protected by trademarks, unlike design patent or utility patents, trademarks are mostly um, forever or sort of perpetual, depending on you have to pay the renewal fee on regular basis. Now, when we are talking about the ecosystem, there are two very important statistics I would like to highlight here. One is Global Innovation Index. So, Global Innovation Index is published by World Intellectual Property Organization, that is part of UN or WTO, where India in FY22 has reached at 40th position from I think 83rd position in 2015. So this is also indicating that in terms of innovation, globally being recognized, and we are making our mark. And this Global Innovation Index covers 143 countries of the world. So that is very significant. Another statistics which is very important from the intellectual property point of view, and especially on the patenting side. This year, that is FY22, India has reached at the 5th position in the world of patent filing, which is remarkable. It is also indicating that ecosystem is supportive and we are getting there where we should be. The only thing is that, covering the back, as Varma sir was talking about, when you have innovative concepts in mind, you need to uh, protect them. And that's how you can, to some extent, cover it. And there are a lot of initiatives under Atal, under startup, where that protection system is basically available. If I talk about the technology and especially under the uh, underwater domain or Sagar, the initiative started by the Prime Minister in 2015, there are several areas where potential is pretty much there. If I look at the top domain areas um, in which patent filing is happening across the world is computer technology, communication technology, and artificial intelligence. At the same time, looking at uh, the frontier technologies, which are like next 5 years, defining the world, or maybe covering 50% of the growth areas are like Internet of Things, IoT, machine learning, deep learning, and things like that. And all those areas, all these domains, I strongly feel there's a lot can be contributed under those initiatives, under the initiative like this, where we are gathering together and doing brainstorming, finding ways how to skill the right people, or how to enhance those skills where people can contribute and leverage. There are certain initiatives which everyone should be aware of, that if we leverage the patenting system, it also helps in um, your funding. When you raise funds, some of the inventors, or I would say most of the inventors, would like to see how protected you are, and IP is the best measure of you being innovative and being careful to protect your innovations. Average patent granting time is usually 2 years, which should not be bothersome to anyone. So once you file your patent application, you can take a call, you can go to the public, you can talk about the invention, because that time, once the patent application is filed for at least 18 months till the time patent application is published for review. It is confidential, and patent office is under obligation that they would not reveal. So it is confidential, that's one. Secondly, you secure your date, so you have the priority over anybody else who comes after you. So that is one thing which many people take leverage, take advantage. Recently, I met one startup that was in the field of two-wheelers, though, but they are coming up on a electric two-wheeler. And considering an area where a lot of companies are getting into, they first, what they did, they filed some 20 plus patents to secure their innovativeness, their novelty features, and looking at their confidence level and the kind of funding they have already received, 150 crores. As I understood, they have already received this month. I think 17th March, they are bringing their first product into the market. So they have fully leveraged the entire ecosystem, and I see that looking at Pune's ecosystem, which is, I would say, after Bangalore, where these initiatives are being concentrated, and our new controller general of the patent, who's actually coming from the industry, this is first time that's happened, is also very supportive towards creating that strong patent system, collaborating with industry, collaborating with academia. He was sharing one story that he was a researcher, and he wanted to file his patent application, which took a good number of years. So he understands the pain, and keeping that in mind, he is keeping the patent system at the forefront. At the same time, whether you can say G20 presidentship that India is leading, there are some questions asked in the past about the Indian patent system. So I think all those things are also playing key role in uh, support of this ecosystem where we are at par. Whether you take any developed nation's name or their patent system, I think we are at par, if not better than their patent system. So our laws are fantastic. Enforcement wise, also things are way better. I can say way better than China, despite China is number one country in the world for filing patent applications. This year they filed 1.6 million patent applications, whereas we at fifth position have filed 70,000 patent applications. So the gap is huge. So the journey is long, but I think we are fully ready to take on. And yeah, I think that's all what I would like to share now, and happy to answer any questions.
Thank you, Neeraj. It was definitely very comprehensive and a broad perspective on the entire startup ecosystem and innovation. So any questions from anybody? Yeah, Kindly mention your name and whom is the question for.
Okay, my name is Aditya Thakre. I am from COAP. मेरा बेसिक क्वेश्चन है कि जैसे कि तलवरकर सर ने कहा कि विलिंगनेस टू एक्सेप्ट द फेल्यूर इन डेवलपमेंट, लेकिन फेल्यूर जब भी आता है तो वो मिटिगेट करने के लिए उससे पहले रिस्क कैसे कैलकुलेट किया जाता है?
I would like to answer your question by another question. Do you really need to assess the risk? Okay, what is the risk in the first place? Okay, if I have to develop something, for example, I have to develop, let's say, a rocket. Okay, the biggest risk is that I will fail, right? Okay, is there any mitigation technology available to me? Okay, see, the problem is, I mean, don't feel bad, but we get too bogged down by these theoretical terms, risk management, etc. If we have to transit from place A to place B, there will be problems en route. Okay, we have to prepare ourselves to address those problems as and when they come. When I meant for, we should be ready for failures, what I'm saying is that the development process is never smooth. There will be issues which you have not foreseen. And as you cannot foresee all situations, it is difficult to assess a risk. Are you getting me? I can assess a risk if I know what are the problems. But my first problem is I don't know the problems. I hope I'm making it clear. You see, risk management, risk assessment, mitigation, everything is fine. But then if you are in a state where you're doing something first time, it is very unlikely that you will come across with all the possible problems in the first go. Okay, I'll give you an example. We were involved in Bharat Forge to develop certain components of a pump. It is a main circulating pump used on board submarines to provide seawater for cooling application to a variety of consumers. Okay, it's an established design, right? We manufactured components as per drawing, assembled it. When the pump was tested, there were problems which we had not foreseen. Okay, and we had to come up with, answers to those problems as we face, right? This kind of risk is very difficult to assess earlier and then mitigate it, correct? So if I have to go for any development, I will not give too much of thrust for risk assessment and risk mitigation. For the very simple reason, I am not in a position to even understand what problems I'm likely to face in future during the development program.
ओके सर, वन मोर क्वेश्चन. जैसे कि लास्ट वीक में सुबेदार सर का वर्कशॉप सेशन हुआ था, उन्होंने वहाँ पे बताया था कि कंटेनर मैन्युफैक्चरिंग जो कि चाइना काफ़ी सस्ते रेट में हमसे सेल करता है, वैसे जब मैं डिग्री में था तब मेरे दिमाग में भी आइडिया था कि कंटेनर हाउसिंग्स वगैरह उस सेक्टर में उतरे या कंटेनर मैन्युफैक्चरिंग में उतरे, तो जो कि रॉ मटेरियल मिलने की जो रेट है जो इंडिया में, उसका रेट भी ज़्यादा रहता है और मिलते भी नहीं है इन कम क्वांटिटी में. तो फिर उस जगह पे हम कैसे कर सकते हैं? और एक कि जब भी कोई भी स्टार्टअप्स के अंदर हम जब उतरते हैं तो फिर मार्केट रिसर्च रहता है या मार्केट सर्वे रहता है, तो कौन से क्राइटेरियाज फिक्स करें जो कि हम फिर उतरेंगे या रिस्क कम आएगी या फेल्यूर जाने के चांसेस कम रहेंगे उसमें?
I'll hand over to Neeraj. I mean, even your first question also, I think Neeraj should intervene. But I just want to, you mentioned about the last week's presentation by Captain Subedar. See, many times what happens is that we do not have the global picture. I mean, particularly when you talk about containers, container is not a domestic requirement. It is an international requirement. So, wahan pe, what I could, I mean, I have not got into the nitty-gritties of that issue, but broadly what, and there are issues of politics also in that, so we'll not go too much into that. But you must understand the global picture also when you do, because see, at some point, I mean, sometimes what happens, my understanding is sometimes startups do not have the broad picture. They have a great idea. They even think that they will be able to pull off the product. But you have to look at the long-term viability of the product. What is the policy, existing policy, and what is the possibility of future policy? Because see, it takes a long while for you to come out with a product. If the shelf life of the product is very short, and if your agility to transform does not match up with that, then you're totally out of sync with what's going on. But in the case of containers is a global entity, and it has to follow the global standards. So you must be aware of the larger, I mean, like what Mr. Neeraj has been talking about. You have to have a global understanding of the whole. I mean, patent is just one. I mean, even what I learned from him is that even when you want to do any innovation, what is innovation which has not happened before, right? How will you ensure that this has not happened before? So even going into the patent literature, like in normal research, we do a literature survey. But literature also is of different types, and there are different areas where the literature is available. One is the research literature, one is the corporate literature. Both have a very different aspect, and their agenda is different. A corporate literature is different where the corporate wants to reach out. The research literature is different where they want to report something which may not have practical relevance. But the way they put that literature is different. And the third literature is the patent literature. What all innovations are. Many times, many startups think that they have a fantastic idea. But when you get into this, what you are thinking has been thought of by somebody maybe 10 years back or 5 years back, and it's already done and dusted. So it's very important to start right. And you also have to have a sense of the ecosystem. Where is this information? Because that patent literature will not be available in the other search engines that you are looking at. So you have to be very specific. You have to know where to go. Right? So I hope I have answered your question. Neeraj, I would like you to intervene on his first question. I think you will be most appropriate to answer that.
Thank you, Arnab. I think you
1 second,
answered.
Neeraj. Sir wants to.
Yeah, sure.
So just first plan is to make a housing containers. Yes.
So why, I mean, there are container houses everywhere, right? In the recent Dubai, you've seen that, no? So see, first you have to decide when you're going in, what is the innovation part? What is the thing that you're going? If you're just going for a manufactured container and convert it into a house, back containers being used as, thing. Example, in the dockyard where we don't have enough place. So we're using containers, right? Because when the ship comes, everything. Rahul Gandhi went all over the place. There were those containers. So you have to find out what is the USP? What is your USP? What is the new thing that you're bringing out, right? That is more important, right? The next step is, once you have that thing, that there is something new or something that is going to be a thing, just an affordable is only price. But we are talking of innovation. If you want to be affordable, though, it could be, you can use less house may, you don't require transportation container. Your steel can be different. It doesn't have to be. So those are the things, right? So I'm not sure if I've answered your question, but I thought you said how containers for homes or whatever it is.
एक्चुअली ये आइडिया जब कोकन में मालिन का जो लैंडस्केपिंग हुआ था तब आया था कि जब यहाँ पे हमारे यहाँ पे लैंडस्केपिंग या अर्थक्वेक जैसे होते हैं तो हमारी जो कंस्ट्रक्शंस है घरों की जो नेचुरली है तो वहाँ में वो तबाह हो जाते हैं तो जबकि ऐसे कोई सिचुएशन जैसे कि अभी माधव धाम में भी ये सिचुएशन चल रही है कि लैंडस्केपिंग की हो सकता है वहाँ पे और अलर्ट भी किया गया है और क्रैक्स भी गए हैं तो इसी सिचुएशन में अगर ऐसे कोई होम्स हम अवेलेबल कर देते हैं उनके लिए या कोई ऐसी स्ट्रेटेजी बनाते हैं तो फिर जो तब नुकसान होगा वो कम होगा कंपेरेटिव
वो तो ठीक है, आप जो बोल रहे हैं एकदम ठीक है। मैं यही बोल रहा था, इसमें तो इनोवेशन तो नहीं है क्योंकि घर तो बने हुए हैं, तुम्हें एक्स्ट्रा तुम बाथरूम लगा दोगे या वो बस वही है, उसमें तो इनोवेशन नहीं है ना। सो यूजिंग दैट एज अ होम और यूजिंग दैट एज एन ऑफिस ऑलरेडी एग्जिस्ट, राइट? नाउ द क्वेश्चन इज why doesn't some company make these thing. That is the basic thing. Actually, there are companies who are making it also, right? So it is not an innovative idea or something like that. And as Dr. Das just mentioned, go if there is a patent at all in India, local patent. That's the next Neeraj, that because he said national patent, global patent, etc. So that's the question I was going to ask. I might have an idea, and I'm interested only in this country. Then what happens?
So same
And
question in my mind.
You know, that kind of a thing, right? So that's the question I was going to ask him. You know, because somebody might have done it somewhere, but in my country nobody's done it. Why can't I do it first time? So that's the next question I was going to ask him. But probably what I said makes sense, right?
Yes, sir.
That's all I want.
Yes, thank you, sir.
Thank you.
Neeraj, over to you, please.
Yeah. Well, I think answer is very well covered. I'll just try to add something. One thing is, since we are talking about innovation, so we have to think from that perspective without fearing, first of all, whether what is there in China and whatever is there. The only thing is, first of all, we need to know what we would like to do. And then comes the aspect of whether what I'm planning to do is new. Is it really first time I am doing? If it is not first time, then it might be a good idea that I, learn it from whatever is being done in the past. So either do some research. Patenting could be one definitely aspect which will tell you the technological advancement, whatever has happened so far. You mentioned about China thing. So China their requirements, their scales, their entire ecosystem, their focus is all different. When we are addressing our problems or the problem which you are interested to address through your innovative idea, which you would like to build up as a business, so review it from the point of view that whether I have sufficient information on that, whether it is new, you can certainly take the advantage of patent database, because patent database gives you information from across the world. This is the best state of art document which can tell you what is the state of art at a particular time. So unfortunately, in our education system also, and even in general practice, we don't pay much attention to the patent literature. As a result, we do not create much innovative products. Uh, when it comes to the startup also, I see mostly it's a trading kind of system where people are using. It's not completely the trading, but trading is taking the major chunk where you are getting things from here and there and then assembling them and providing the services. Look at what happened 2 years or 3 years ago, and it's still impacting when chips or semiconductor issue was faced. And what we found out that other than Taiwan, which is, and listen to this number, one company in Taiwan which is making 60% of the semiconductors that world requires, one company. And then there are a few companies in Japan, I think Vietnam and all. But that semiconductor is largely being produced by Taiwan. And situations like pandemic, we did not have any solution. We don't have any manufacturer. So look at those aspects, look at the gaps and look at your skills. And then if you can fill those gaps, I don't think there's any hurdle. On the question what Varma sir raised about, I think it was if it is not patented here, can I go ahead? So yes. So if it is not patented in a particular country and you want to start that business, you can go ahead. The only aspect that you need to be aware of, that once that product is being manufactured, if it is landing into that country where it is patented, then it may be a risky affair where it would be considered as infringement in that particular geography. I hope I answered.
Like, that's exactly because uh, we have ideas that something has happened there, but I know that the product will be there, but I can have a different idea on how to get it done. So I have a process patent. So I can go
Yeah.
for a process patent, even if I'm aware that something has happened. Obviously, he's followed some process to get to that thing. But I'm now thinking of on my own, and I have a process to come to a product. So I can patent that in this country, because I really don't know whether his process same as mine. I won't know. But when I come to you for patent, you'll probably check and say, hey, this is patented in this country. You still want to go ahead with this or not?
Yeah.
Am I right?
Absolutely, sir.
In any case, if I get to know that it is very close to something, I can tweak my.
You can work around.
Yeah, I can
You
work
can
around.
improvise, and
Yeah,
that's how the innovation process works.
works. No, basically, it's for youngsters, because most of the time, as you rightly said, patenting is something, अरे यार patent लेने में बहुत मुश्किल होता है. This is the first
नहीं.
thing I have seen. नहीं, you're the first person who's saying it is not, because I know of some of the young guys who have ideas, who are also done some what is that called? Their own
POC?
yeah POCs. They've done the product concepts. They've also tried it out. You understand? But then I either they have not read the whole thing properly, but their reaction is, because I will always say this is a damn good idea. I haven't heard this before. For heaven's sake, go and patent it before you start. So therefore, an idea can be also patented.
Pure concept with
Concept.
some technical knowledge, then it can be patented, and then you can further actually prove it, which would definitely help you.
Okay. But the easier would be have an idea, make a concept, and then go for patenting. You at least know what you're getting into. Correct?
Absolutely.
Thank you. Actually, these questions are meant for those people, because this is in my mind. I'm not going to use it, but I hope it covers some of the things in your mind. Thank you. Thank you, Neeraj.
Thank you. Vijay, you want to say?
So Neeraj, I have a question. Like, how do you quite familiar with doing a research gap analysis and doing a research literature survey and other thing? A patent survey, an easy way to explain to all the audience. Patent survey, is that patent is already done? Is it available online? How do I search it? And is it available or?
It is available online. You can go to the World Intellectual Property Organization's website, which
Neeraj,
will
I think
give.
if I can interrupt you, you can actually cover this in your lecture post lunch.
Sure, I can. But quick answer is
because Vijay may not be able to wait till then. You can just explain that to him. Yeah.
You're right. So quick answer is that yes, it is available. So there are different offices, websites, whether it's USPTO, US Patent Office, Indian Patent Office, Singapore, etc. Some of the patent office provides the information of all the global patent applications if are filed and are published. So you can see that. World IPO is a sort of centralized organization which will publish all the international applications, or we call them PCT applications. So in short, answer is yes, it is available. It is freely available also. There are some paid database which are used for some analysis, etc. But for starting an idea or things like that, you can actually search on your own.
Thank you. Thank you so much. Thank you, Neeraj. Thank you, Admiral Varma, sir, Commodore Talwelkar, sir. Vijay, thank you so much. We'll take a break, tea break, and then we'll come back for a session by Dr. Vijay Kumar. Thank you so much. Welcome back. We'll continue with our second session for the day. As you know, we are trying to piece together various aspects of the underwater. Now, I would like to invite Dr. R. Vijay Kumar, Associate Professor, Department of Ocean Engineering, IIT Chennai. Vijay, you've heard him in the morning. Somebody who has almost 25 years of academic experience and almost 22 years of experience in the Navy. While introducing, Vijay did not mention his achievements in the Navy. I know him very closely, and in the Navy also he has some remarkable contributions to indigenization. He was in the design directorate also. He has been in the dockyard as a manager, and for technical officers in the Navy, being a production manager in the dockyard is one of the toughest jobs one does. And knowing Vijay, he has done a great job there. Some very critical projects. He was even involved in indigenization in the dockyard also. So I'll not take any more time and I'll hand over to Vijay. Vijay.
So, very good morning. Thank you, Arnab. I have split my presentation into 3 heads. The first one is to introduce to certain hydrodynamic aspects of facility what we have at Ocean Engineering Department, IIT Madras. I'll take few minutes there. Then the second set of presentation, I made it into what is my research interest. And the third one is, of course, on the robotics. Even there also, I have split it into 3, in which introduction part of it is just to give a glimpse of it, and what is the work I am doing on the hull form development and other things. And the last one is what all the certain changes and other things what could be bring about in the underwater domain or robotics domain that is going to change in the future. So first few 5 to 10 minutes on the hydrodynamic testing facilities which are there in the Ocean Engineering Department. Ocean Engineering Department is a part of IIT Madras, one of the 13 department where initially the department has come out as a center, then it's become a department. There has been a lot of German funding and German collaboration at the initial stage, and certain facilities which have been set up then 50 years ago still running fine and it is working. And if you look at it in the research group, we are a group of 5 verticals. One is naval architecture, 5 faculties of the naval architectures are there. Then offshore structures, ocean science, petroleum engineering, coastal and near shores structures and the process. The petroleum engineering joined very late, and it's 3 to 4 faculty there. Naval architecture 5 faculty, and other sides 13 faculty. A group of 23 faculties working together to this. We offer BTech in naval architecture and ocean engineering, and a dual degree. The BTech converting into dual degree, 15 of them. Then we offer 3 of the MTech programs. In that MTech programs, now we have clubbed all the 3 into ocean structures. Initially, it is ocean engineering, intake of 12 to 13, where a lot of naval officers come and do. I also did my MTech program in way back in 2002, 2004 in that program. Then ocean technology, a user-oriented program for NIOT. NIOT has got certain specific syllabus, and we conduct the course. Then this one has stopped. LNT 1 has already stopped. We are converted into ocean structures. Then we have got MTech in petroleum, 12 to 15 is the intake. Then we have a huge number of MS as well as PhD program. In that MS every year 15, and PhD almost 10 to 15 every year. In the month of June, July and December we have an intake. A total of 550 is the student strength what we have in our department. In India, of course, not many institutes are there. We rank number 1 in terms of publications and based on the publications. And main hydrodynamics laboratory we have. This is one of the unique features. If you generally visit to IIT Madras, please come to our department. It will be my pleasure to take you over there to show the facilities. I got certain videos on the slide to show it. We have a wave basin. We have a tank, towing tank, 4-meter deep water waves, 2-meter shallow water flume, then 2-meter wave and current flume, shallow water basins and the glass flumes. And we have a discovery campus now 36 kilometers away from that, where we have a very huge facility of coming is a seakeeping basin. is coming, shallow water sea caping basins where a bigger model can be done. It's completely indigenous and a huge facility is coming up there. Further, we have a idea of having a tank facility of 500 meters long and having a towing carriage facilities. Okay, speak about it. If you look at it, the 6 to 7 test facility under one roof in one institute, I don't think so anywhere else it exists. I can proudly say that, because they may have a bigger than us, bigger facility, but it will be one or two. But we have these 7 facility at one places. Other than that, we have instrumentation lab, model making facilities. I'll show you some of the photographs. Petroleum, okay, petroleum engineering, offshore structural dynamics lab, then certain other small labs we have. This is one of the facility where we have a wave maker. The wave maker is a paddle. That paddle runs to jumping and maneuvering analysis. The sea keeping analysis, that a model is there, model ship and a model equivalently modeled oceans created into the laboratory, and how the ship is going to behave, how much is going to pitch, how much I'm going to fix the equipment, how it is going to behave. And maneuvering is that when I want to do the path, how it is going to go, how the rudder is going to be effective, and how is the zigzag or spiral path maneuver if it takes. Such kind of experiment we can do. Okay, that the wave buoy, this video should be running. That wave buoy is the one which is that tsunami buoy has been, the hull form has been designed. It's way back in 2002, 2004. Another one is another ship, a container ship's the stability analysis in the waves. The static stability in the waves, how does it going to behave? That was being analyzed during that time. This is another one where they were manufacturing certain amount of pontoons or non-propelled cargo and then stack it over one another and transport from a coast in China to a Norway. How it is going to, whether it will have a stability or not, or whether how is the vagaries of the seas, how it is going to behave. That analysis was done in one of the waveform. You can generate all directional waves, that all the flaps, 50 flaps can independently act and then create a direction of the waves. This was installed with the help of Germans and still functional. Now in the Tayur camera is completely indigenized, and none of the parts, some of the parts like motors and other thing we have it, and much more huge, much bigger and larger waves which we can generate has been done over there. Next is the towing tank, where I am the in charge, where I was telling we do the resistance predictions, design the propeller, and then how the propeller on water characteristics, then fit it behind the ship, how it is going to perform behind the vessels, and all those tests will be carried out there. This is around 90 meters in length, 2.8 meters in width, and 3 meters depth, and it can go up to a speed of 5 meters per second. Now it is refurbished, and this one what we are showing is a planing hull, and another one what I was showing is the wake behind the hull. The problem I just stating it, the wake behind the hull, how an obstruction can create, and then that can induce a vibration onto the hull part of it. Hull propeller interactions can be studied. There's certain model making and certain tests which are done. So there you can see that paint flow test, even any appendage need to be fitted behind the hull. How do you do it? That kind of test. This facility which is there, this is an open water facility with the propeller with the cot nozzle. How it is going to perform and the effectiveness, both accelerating and decelerating cot nozzles, whether it is going to give extra thrust, that can be there. Another one is the pump jet propulsion device, which is being tested over here. This is the propeller which is having water, it is coming out of it, and the catamaran being tested, and all those test facilities we have. Then another flume where we generate the wave and then test the offshore structures, the forces coming on the structures. This is the one where we will able to test that. So we have got a deep 4-meter depth in the to represent the depthness within the basin of 3 meters. A deep well is there. There we can place it, then move it, and or if it is a floating object, float it, and then able to find out the motions and the forces coming out in that. This is the 2-meter flume. It's a shallow water flume, able to generate the shallow water near the coast, the coastal structures which are going to be designed and built, and what all the forces going to come, how to lay the breakwaters and study on the breakwaters, and displacement of those things can be studied using this 2-meter or shallow water flume. Then we have a parallel 2-meter wave and the current flume. It also generates a wave, also generate the movement of the water. Current also is there. There also we used to study the breaking of the waves on the structures, then on how the coastal structures were able to withstand such kind of forces. Model study on that is being there. Then we have a non-intuitive measurement device like a glass flume that you don't interfere. The instrument also will not interfere. Your instrumentation is generally PIV. Have a particle image velocimetry and then measure the waves and wave velocity, current velocity, and can be measured using the glass wave flume in this. This is the one on a shallow water basins. All other basins are depth is 3 meters. And this shallow water is 60 centimeter depth. All the coastal structures where a distorted model can be generated and then studied. This is one of the structures which are being studied for one of the beaches in the one of the coastal structures in the US. That is being generated over there, and the currents and the waves are generated on the sites, able to study this kind of shallow water basin. Then these are certain models. We have in-house model manufacturing. These models has to be made as per the ITTC recommendations, and these models are being manufactured as per that, and then do the test in the towing time. We have the model fabrication facility, certain instrumentations. We have been involved with the nations in the nation building activity from age memorial. When Virat was having the ski jump, it was not having a ski jump, and we had to design the ski jump and having it. Then FDN, then GSLV launch. Off late, you would have seen in the news also, one of the helicopter accidentally landed on a water. Then the 4 floats came out. Those 4 floats are able to make it to float. They towed it for almost 4 hours and then able to bring it to it. This was the floats was designed, meaning of course HAL for HAL, the floats, all the analysis and design was done in our place. Now I am doing it for the LUH recently. Then certain coastal protection measures, groins off the coast of Chennai, on almost, if you take from this Calcutta to this side, Gujarat, anywhere on the coastal structure, there will be an imprint of our department, ocean engineering department, in certain design, analysis, or even in constructions. Somewhere or the other, some faculty will be involved in that. Okay, so these are the another one is on the biomimicking. In the robotic side, where you are familiar, this biomimicking propulsion device is being researched by Professor Krishna Koti, just retired. He is spearheading one of the projects for NRB, where they want to make one biomimicking a robot. They are in the stages of making that. I will talk to you in the last slide of my presentation about that. Certain things which have been designed, experimented, and even the small prototype are being made. Other protection strategies on the coastal areas. These are the works. Breaking of waters, appointed breaking of waves on the structures, the forces required, and the measurements being simulated and studied. Certain coastal protection, wave energy. So these are the hydrodynamic activities which we get involved in the faculty of 23 faculty at the one. Not only that, there are many other structural and other things are there. Since I am more interested in the hydrodynamics, I prepared a presentation to showcase certain activities, hydrodynamic activities which we undertake. Now coming to the research activities which I do, I work on the 10 verticals, or in fact 4 verticals and 10 different topics. I have 7 PhD students are completed under me, and 14 are doing currently and doing under the research activities. So somebody who is interested in joining my team can join. So I put 4 verticals. Okay. So once on the ship aerodynamics part of it, in that I work on the 3 verticals within that ship aerodynamics. Then comes to the green ship initiatives, where how to reduce the drag of the vessel. I work on it. Third one is the gliders, underwater gliders. 2 PhD students are working, and some on the propellers. Actually, morning he was mentioning there are no designers are available, but only manufacturers are not available, sir. That is the only thing. Designers of the propellers are available. I work on reducing the noise of the propeller on a non-cavitating regime. Not even going to the cavitating regime. At certain speed, at certain pressures, the propeller cavitate, and then the cavities implode and make noise. I'm even working on the propeller to non-cavitating. Even below that, how do you reduce the noise of the propeller is the one of the research area which I am working on. So first vertical is my research work. which initiated. This is the when we have built the project 15 and then went for the first sailing. There was a problem that the smoke from the exhaust have started coming into the intake, and the ship had an issue. So it was being analyzed by Professor this one, my two guides, Professor S.N. Singh and Professor Seshadri. Then from there, that idea of how to mitigate this problem for whole when we want to do the superstructure analysis. So this was my PhD topic. We have come out with many ideas. Now we are able to give to the designer at the earliest stages of design what should be your mast height, what should be your funnel height, where it is supposed to be placed, how far it is supposed to be placed. You can pick up into that level. So two PhDs have been done. One was prior to me is Commodore Kulkarni, PR Kulkarni has done it, and then I followed it upon and then did the second part of it to give a conclusions. So after that, many research activities, even the private shipyards which are doing the defense one, we have done the certain analysis and given. Now two of the ships which have been awarded, they are coming to me. We are going to do both experiment as well as the CFD studies to avoid to have the smoke, to avoid the smoke nuisance problem on the warships. Now coming to the second part of the aerodynamic, where the helicopter landing on the vessel is the most, in the naval vessel, is the most unsecured place, I will like to say, or most difficult place, because there is a bluff body. In aerodynamic pass, a bluff body is there in front of it. And then I want to land a helicopter there. While landing the helicopter, the aerodynamics part of the whole of the ship is completely changed. In that object, helicopter is going to land. Many accidents possibilities are there, but that is a place you has to have the best of the thrust and the thrust control, and that is the time where the sudden change in the airflow pattern occurs. So how do you avoid it? So we have come with certain innovative ideas, even implementable, non-implementable innovative ideas, worked on it, and we are able to do it. The same also, every ship which is going to be constructed, they do this analysis, CFD analysis and the experimental studies to avoid to reduce that problems on when the helicopter is going to land. 3 PhD students have completed work on it. We have done a Naval Research Board project on that. Certain data are available, still being referred to me or our team particularly for this analysis. The third one is also related to the Navy, where aircrafts going to land on an aircraft carrier when we have an issues. This also just we have completed this project, and we are going to have decimate this information what we have done on the 24th. We are going to have NRB panel meeting there. We are going to decimate. It will be available for many people to attend. And here also 2 MS students have worked and 1 PhD student have worked. It's a typical burble effect. They call it as a burble. Just before the aircraft is going to land, the variation in the vertical velocity, it's given in the bottom, variation in the vertical velocity and the horizontal velocity, just sudden change. How is the going to have an effect on the pilot when he is going to land on it? These 3 are directly relevant to Navy. They are now coming to the green ship initiatives. The first one on the air-induced, bubble-induced drag reductions. When I inject the bubble in the front of the vessel, how is the drag, frictional drag of the vessel is going to be reduced? So it's a promising field, and our ship has been now installed with the bubble-induced drag reduction in the by Japan, and they have in one of the Japanese vessel where they claim 10% or 6 to 10% of the reduction in the overall energy efficiency of the vessels. So we have taken a container vessel. We have taken a flat bottom vessel, and it's more like a cement carrier or a flat bottom vessel, and able to inject the air and then find out how much is the drag reductions. We have 6 to 7 publications on this. 1 PhD has been completed, and in order to carry forward, how is this effect on the shallow water? Because we are all talking about the Sagarmala projects, and all the vessels are going to go where the underkill clearances are very low, and how can I reduce the drag even furthermore? So we are taking up that on a shallow water effect, and what happens to the maneuvering effect of these vessels when this vessel is proceeding ahead. So the maneuvering part is done by another student, and shallow water is being done. Particularly the maneuvering is a keen interest with the Germans also. There is a student who has gone on a DAT scheme to do a collaborative work on this shallow water maneuvering of the using bubble induced drag reduction. One of the experiment which is being conducted in our towing tank, where we are able to visualize how the bubbles forms, how the bubble coalesce and how the bubble splits and how much is the total area it is going to occupy and how is the frictional drag reduction of the vessel is happening. Next, another one is of quite interest to any high fruit number vessels, vessels which are going at little higher speed like naval vessels. There are simple objects like introduction of a flap at the stern of the propeller will reduce the drag of the vessel to 6 to 10% of weight. So we have taken it up, and this also is as a part of Green Ship initiative we have taken. IMO has mandated that at 2025 and 2030, every vessel has to incorporate certain measures, commercial vessels to incorporate certain measures to reduce the greenhouse effect, the NOx and the SOx productions of the vessel has to be reduced. So this is quite popular, and few of the firms are approaching us. Coming to the propeller, study of the propeller acoustics is one of the quite important one, where the propeller geometry of the skew, rake, and certain tip, introduction of the tip to the propeller blades and the propeller hub, how does it affect the noise propagation even below the non-cavitating regime, in the non-cavitating regimes, not even the cavitating regimes. We have found that skew has got a certain effect, and doing over skew also will not able to produce the thrust. We have taken the already proven propeller DTMB 4119 propeller, and it's certain experiment in our towing tank, and also numerically we can predict the noise. Even before that, also used both CFD as well as the noise prediction methodologies to predict the noise levels at the lower frequency. Higher frequency we can get it with the experimental methods, but lower frequency we can only, as of now, we can predict by the numerical methods. This is another propeller where we are testing the composite propellers. Even the composite propellers are quite in the literature for many time, but use is not much. So how is that the weight reduction of the composites? It could be as strong as the, or even I can row it in a way it can be where it is, can be even equivalent or comparable strength of the normal metal propeller. So here also we have designed a propeller for vessels. We manufacture a small two composites, and next idea is to stitch the strength to my requirement so that the profile, the aerofoil profile will change with certain thrust to produce the efficiency level better. Okay, so this is under testing now. The boy who has done it has been called to the Cyprus, and he has been awarded one of the medals, and they have offered him a job. So it's quite promising, and we have already have 20 centimeter, 30 centimeter propeller manufacturer doing the test. In order to measure the deflections when it is rotating with a inbuilt this one inbuilt sensors, it was a difficult item. So we have evolved a method. We have applied for a patent, and first patent licensing has been awarded to us for this propeller deflection measurements. Now coming to the underwater one, I work on gliders. Me and Arnab also started long time back, 7 to 8 years back. I'm also show you a photograph of them taken. I work on two type of gliders. One is a myring hull form gliders, and most on the hull and the maneuvering characteristic of the gliders, not on the any other part. So this myring hull form and the blended wing one, we are working on it. We will discuss about this myring and the blended wing into the as we go on to the robotics part of it. Then I also work on the maneuvering characteristics of the motions, where ahead there have been a lot of research has been done. But when the vessel moves back, do I going to move in the same direction in which I desire to go? It so happened that certain LSTs, when move back, it was coming back to the shore. So in such kind of vessels, can I able to get a directional stability while moving back? While moving back, do I have the directional stability? Research on that. Of course, I told you about when I do any interruption in the hull in form of vane, in form of flap, in form of inducing certain air, then how do is going to affect my maneuvering characteristics? So that also we are doing. These are the 10 verticals I work on it. I have 14 students with me, PhD students with me, who work on this work. Now coming to the underwater robotics, I also prepared few of the slides. I will go with this. I'll be slow and steady in this part of it. What is underwater robotics? You have to use the robots for explore, study, and manipulate the underwater environment or underwater complete domain. So it combines various fields. Naval architecture, I missed it. That is important. Naval architecture, because we have to understand the weight and buoyancy much properly, and the stability at the floating conditions and as well as on the submerged condition, and when it is going to transit. If you don't make that right, thinking thrusters will manage it, it is going to cost you in terms of energy. So naval architecture, mechanical engineering, electrical engineering, computer science, of course, some kind of communication to transmit the data, and what all the robots is going to do the work in such environment. So typically underwater robots are known as AUVs, autonomous underwater, and remotely operated vehicles. It could be a glider also, and it has got sensors, cameras, and other requirements so that you are able to do the function of gathering the data and also underwater, study the underwater world. It has got many applications in the deep sea explorations, oceanographic research, underwater archaeology, pipeline inspections, marine biology. These should be able to operate in the most hostile environment, hostile in the sense in terms of the NaCl, the aqueous medium, and difficult to human to access, make them invaluable tools for scientific research and applications. Coming to the development of robotics, innovations in the many of the activities like bio-inspired designs that mimic the movement of the fish, improved battery technology, machine learning algorithm to enable robots to learn their environment and then move about it. I have got a certain pictures of this underwater robots. The heading was looking like it's also called underwater litters. So it litter the whole world with so much small objects. We'll go in detail with one another. Let us look into the applications and the motivations behind it. If I have in the x-axis the task which it performs, the underwater robots perform, and the power which is going to consume on the x-axis, I can split this into three components like gliders, AUVs, and ROVs. The more the task you require to do and the power consumptions are more, then the operability and the class in which you fall is also there. If I take gliders, it will be only hydrographic survey. We'll spend much time on the glider. Otherwise, it could be without the help of the ship, mothership, I can launch it and then have it in the form of gliders, long endurance vessels. Then AUVs, you require a mothership, but still it is not tethered. If you have tethered, then you have vagaries like this in this form. That two measurements which have been taken when the sea was rough, one with tethered, one with non-tethered one. You can see clearly the image or the data accuracy of the sonar which has been able to scan. So AUVs, autonomous underwater vehicles, is much more reliable. It can give much more reliable data compared to a remotely operated this one vehicle which with a tether, which the tether it is itself is going to have a issue. I will again touch upon this in the few slides little later. This is one of the yes sir. Okay, this is one of the side scan sonar image of the sea surface in front of one of the straits which have been taken. These are the applications which are looking at. So which will able to give you where the hydrothermal vent is there or where the plankton growth is there. Those things can be obtained. Under ice operations are more difficult than compared to the one which is not under the ice operations, where not only it has to scan at the bottom, it has to scan even on the top to know what is the profile on the top so that it's able to maneuver properly. So the requirement doubles up when it wants to do the under ice operations. Then comes is the certain underwater robotics which has taken the scanning of the images, high resolution mapping of the underwater one can be there. It can be even used for the covert operations. The covert operations could be for surveillance, mine detections, covert insertions, or even you can go and deploy your sensors in the locations in which you want to be there. One such area is AUV, which is doing for the current profiling and the data monitoring, and then you can use the ROV for that. Now coming to the ocean samplers, we have many samplers are there. There is a mood buoys, which generally take these instruments. These mood buoys are the one which is anchored to the sea floor, and used to monitor the sea in terms of temperature, salinity, currents, and in a particular fixed locations. Another one is Lagrangian drifter. The drifter is, we call it Eulerian and Lagrangian format in the max you would have studied or physics you had studied, where Eulerian Lagrangians moves or drift along with the currents and then able to map the all the requirement of the currents and other things, movements of the circulation of the water over the mass over the flow, and then it could be for a short-term studies, space-bound sensors, unmanned surface vehicles, picking up a lot into the one where you want to have unmanned surface vehicles where autonomously it will be able to run. Then ergo floats, underwater gliders, and you have cabled seafloor observations. Then human operated vehicles. It's also picking up human operated vehicle. India is making one of the human operated vehicles, unlike a submarine, deep sea submarines. Then Hadal landers. These are instruments designed to study the deepest part of the oceans, and known as the Hadal zones, and able to deploy from the ship and then able to get the data from there. If you look at it, typically the depth ranging, operating depth ranging, it can operate in a shallow water, coastal waters to the deepest oceans. Somewhere it can even go up to 11,000 meters. So one of the vessel designed is Neeraj, Neeraj, which goes up to that level. And typical endurance is around 5 hours or AUVs, and little long endurance is 24 to 36 hours. It can sometime it can operate up to 20 days. They claim REMIS 6000 can operate up to 20 days, and there is a lot of market pull for this kind of AUVs, oceanographic, military, commercial domains. So there are many people are into it and making it small and bigger as per the requirement, and even we are also into it, and we also want to have a AUVs for the specific purpose in which we are looking at it. I'll come to it little later. So there is a rate of advancement in this sector is very, very fast. You have to be competitive, it should be there. Then we would like to have an unattended deployment and development. How I am going to do it? I deploy it once and then get the data for a long time, and then able to process the data without any unattended one, because it's a characteristics of AU and RU. Otherwise, going on a ship, it will be attended. It could be a long range system in the development is the one. If you look at the cost analysis of this one compared to ROV and the AUV on the heading like mobility, put it on the heading like mobility, transit, survey, turns, tracking of boats, reporting, surely I will say that AUV has got a lesser cost compared to a towed array survey, where we got to have a mothership or a boat or a support system to do it. But you have the data, the unlimited power supply can be given to the towed one, whereas the limited power supply is the only disadvantage which is come to the AUVs. There are certain another one which they come is Dorado, which is an autonomous underwater vehicle. It's a modular concept that can be customized for the various applications, where you have different modules like semi-fuel cells, a battery module, or a semi-fuel cell, tail section. Tail section will have only the propulsion. Head section can be changed. Middle sections can be changed, so that you have modular a set of one. We can, as per the mission requirement, you can have it. This one is a modular AUVs or Dorado. Then you can look at the hull form also. The hull form is completely mirroring hull form with many modules. Then came is the autonomous benthic one, deep sea explorations. It operates from 4,500 meters to 14. It goes, and you see the hull form. Hull form is kept in 3 modules. You can interchange the modules, and one does the function of propulsion, another does the function of your side scan sonar, and even there you want to keep the sonars in much little away from the noise generating your thrusters, so you are able to place it there. Then you have certain other functions which does is the it's quite good in maneuvering, because many thrusters can be positioned in the way in which I would like to have it. It's a benthic explorer. This is another one is a sentry. It's generally used for exploration and mapping. This is also developed by Woods Hole Oceanaric Institute. It's an institute developed one, and it has gone up to 6,000 meters and able to make exploring at the deep sea. And you have another one which is there in the photograph. You can see able to go there and then assist, communicate, and then underwater communications able to have a command and control from another manned submersible. Seabird. Here you can see the hull form, split it into two, and then it's used for a deep ocean benthic survey operations. Highly maneuverable at the near the bottom where it is maneuverability is required. High resolutions imaging and bathymetry it can do, and it can go up to 2000 meters rated. Some of the images explored by this. So another one, Neeraj, it's a deep diving remotely operated vessel designed to operate at a depth of around 6000 meters. And actually, this one in 2014 mission, it has gone up to 10,902 meters depth. And then after that, I think, as per the record, it collapsed. It went up to the depth, able to collect certain data and recorded this near record for a human operated vehicle, it has gone. So it was lost during the mission due to catastrophic implosions, the pressure levels at that place, and at extreme depth. And despite the setback, it's a groundbreaking accomplishment because it able to go to that kind of this one. They named it as Neeraj because it can change that god, no, that changes its forms as per the requirement. That is why they named it as Neeraj into that name and then used it. Quite inspiring read if you would like to go through it and then look at this accomplishments. Now coming to the Indian scenario, many people are making it. One such is NIO team. They have many smaller AUVs. They are called Matsya. They do for environmental monitoring. Mayur, I have not put the photograph of that. All the things I have not put it. Inspection of pipeline and cables. Setu for seabed and collecting environmental data. Samudra for exploration and research. Daskin for collecting oceanographic data. So these are all small AUVs they operate. And one. What is in figure shown is the deep sea mining one, where they are going to do the deep sea mining, where the nodules, cobalt rich or manganese rich nodules are there, able to go to a depth of 6000 meters and then want to do the harvest those nodules. They have a lot of difficulty because this is from the ship launched from a A-frame, and they have a long cable to run till the 6000 meters depth, and this should have adequate buoyancy just to float over the seabed, not to give the load to the seabed, and then able to collect the nodules and then crush it, pump it on top of 6000 meter. Every aspect is a challenge. Every aspect. Going to the deep sea and then having a ship to lower it, the motions of the ship should not get transferred to the vessel. So many times if it get transferred, then the tether and the cable breaks. You lose the rover at the bottom, and when it is at the bottom, the moment the bottom soil is so loose and it cannot bear the weight of the rover, then you have the problem there. It gets stuck, or you are not able to collect. When it moves, it generates the hydrodynamic forces, the nodules get separated to another side. You are not able to collect, economically harvest. So we are also involved. They are doing it, and they have got quite good advancement. These challenges need to be met. In fact, you have to look for a ship where the seakeeping characteristics, that is the heaving and the pitching and the rolling, these three motions are small, or how do you have it avoided, or how do you not to transfer those motions back into it. All is such study. We are little bit involved, and we will be doing some work on these aspects of the one. Next is the everybody would have known about this. NIOT is making the manned submersible. This goes to a depth of 6000 meters. A 3-man can go. It's really a technologically challenging aspects. The hydrostatics and the resistance, hydrostatic and seakeeping study I'm doing for them. We are working with them in this aspects, of course, structure and other things. They are managing a small portion of the initial study. Of course, it has to flow upright and do the hydrostatic part of it rightly. We are doing something for them also. Now coming to the aspects of gliders, which of my interest, and I am doing certain research on this. So I have two students. One is Lieutenant Commander Shashank Shankar, who is doing PhD under me and is almost completing this and submitting in another month. And another candidate is Mukesh, Gugila Mukesh. He is a PMRF, Prime Minister's Research Fellowship candidate. And I should give a credit to them. So that's why the work which I'm going to show it in next few slides are the works which are done by them under my guidance. So the question arises is, what is a glider? Glider is a one which we are very quite familiar in the air, which glides in the air, which does not have any propulsion device. It doesn't have a propeller or it doesn't have a turbo engines, but it glides. It uses the wind flow patterns and adjusts itself and able to glide in the air to a certain level. So the people who are good in flying the kite, he knows when to give the thrust from the back or when to change the direction of it, or how do I orient the angle of attack for the wings or the glide to float the way in which it needs to float. So he will be able to do it. So a kite when flown in air does not require any thruster. It uses difference in altitude to create the kinetic energy and then keep alight. Can I do it the same in the water? So in underwater AUVs, I have put the underwater glider. Similar to, it's an autonomous one. It glides very slow speed using the principles of change in weight. So if I change the weight, make it positively, negatively buoyant, it will try to drop down without anything. While dropping down, if I have a wing quite big enough, able to produce the dropping down to a moving in front, I will move front as well as drop down. So this can be given as a propulsion in front. I don't have a thruster. So changing in weight, a measured quantity of changing in weight will play a role to move forward if I have a wing. So that is the principle in which it works. And being it is buoyancy driven and there is no thruster, it is
अरे लय अवघड लोक आहे यांच्यात जर राहिलो ना आपण लय मोठे विषय हा.
yeah, it is characteristically small. So in the figure I have given, it follows being buoyancy driven, it is small, not very big. It's very small and it consumes very low power. So being buoyancy driven, these gliders are small. It requires very less power. And one important factor is very, very long endurance. And the cost is very low. Endurance can be as much as 6 months. They are prone, it has been going around the globe for 6 months. It follows a typical pattern. That pattern of the path is called the sawtooth pattern. Okay. And by adjusting our buoyancy engine, what we are going to have, we can determine the path in which it should follow. Okay. And it can have a pressure sensors, tilt sensors, magnetic compass, and every time when it comes up, it communicates to satellite, whatever the data it is collected, transmit to them, and then can come to the store station, and then it can fix itself where it is as it is following, or not that it is drifted away from its original position. So the collection happens at the top and the bottom. Actually, the figure which electronic glider, and this uses for descent, you can see while descent, it is negatively buoyant, while ascent, it will be positively buoyant. So that while coming in. And if you look at it, the accelerating phase is very small duration in which it is going to accelerate. After that, it follows a very constant velocity to go down and come back. So it is one of the it's quite a novel idea. It is happened in the 1990 or 1995, in this range only the people thought about this kind of gliders. I'll repeat the slide again just to make sure that is that the operations when it is slow, small and long endurance, it cannot do too much of activities like scanning and other thing. It's mainly used for hydrographic survey and some kind of alert system you can have it. When you look at it, the legacy gliders are all in this type where I have a ring type 1 axisymmetric all are my ring hull forms. These axisymmetric hull forms are the 3 legacy gliders I have listed are spray gliders, sea gliders and Solcombe gliders. If you look at little close, length is around 2 meters, 2 meters to that range, and then weight is around 50 kg, 50 to 60 kg, and wingspan is around 5.502 centimeter square. That is the wingspan. If you actually put it, the length of 2 meters, the length of the wing also will be around 2 meters, thumb rule, if you look at it in that form. So that is required to generate the lift or the propulsion in the forward directions. This is the typical legacy glider configuration. Little in detail, I put it on the next one. This is the Scripps Sea Spray, which is a volume of about 250 cc. It can make 815 cycles, the what which I said. When it goes down, it may in one cycle it may traverse about 5 kilometers. You can even program it, it can go up to 5 kilometers to that range, and the glide angle, that the angle in which it goes is around 20 to 25 degrees, and the velocity is quite small. It is about 1 knots, it is 1 to 2 knots, and the range is about horizontal range. It would have traversed, I said 5 kilometers, no, to 4,700 to, it clearly gives you the picture how much is that. Length is 2 meters, wingspan is around 1.1, and the mass of the payload and GPS for navigations and other things. So certain pictures of the gliders, what do they do is they have the antenna into the wing or on the tail. So when it comes on top, it rolls over to 90 degree and then use that as an antenna to communicate, and then go back, roll back, and then go down. Some of the pictures of it, I have put a sea glider, Solcombe glider, and the sea spray. The sea glider, the one type of glider is the one in which the tail is used as the antenna. The tail, we have the antenna, so it goes down, come back, and then able to communicate in that. And the communication device used is also is very simple means of iridium based, satellite based phone, so that the data transfer could be even much more cheaper. So when this has come and it goes to a depth and then come back, it's a sawtooth pattern. I want to have this in one single band of depth in which I wanted to maintain. How do I go about it? Then I have to change the hull form, and at the same time it should use less energy. That changing the hull form and coming out is the this myring hull form. Sorry, this is the what is that blended wing hull form. It similar to a Z-ray. It's called Z-ray glider. Typically, they want to identify an object moving within a certain depth range. I want to track it, so it will be able to track within that space and then able to come up and communicate. You can understand it could be a submarine, it could be anything. So this completely the wing shape changes, and it's like a manta ray fish, manta ray. Okay, so all these things are quite difficult to maneuver. The requirement of the maneuvering study was the one which I have undertaken. This can go to, it can have generally it can have a CTT platform, range up to thousands of kilometers, weight is 50 kg, speed is around 1 or 1.5 or even less than 1 knots. Communications, they can use whatever the iridium based or book-on communication system, what is there. So now coming to the maneuvering study, these gliders are characteristic by a large wingspan and a cylinder hull form. And it follows a sawtooth pattern. They call it in terms of Dubin's score analogy. Dubin's score analogy means everything it can do is move forward only. I can't move back. But at the same time, if there is an obstacle comes, I have to avoid the obstacles. I have to make a turn. How do I do the turning? By this. That is what the maneuvering characteristics are going to have an impact. How is the hull form is having a performance effect on this? If I want to do certain places, I can want this glider not to go the way in which it want. I want to give a station keeping glider. Then what kind of hull form I should make, and what kind of this one I should do to have a station keeping. The station may be a 5 kilometer range. It will be keep going down, spiral maneuver down, and come back on the top. It able to domain, it will have a domain of 5 kilometers. Within the domain, I want to able to maneuver that. So such do it. For that, individual hydrodynamic coefficients have been taken up, studied, and look at the hull form and what will impact. Can I have certain weights within the hull form which will be able to do both anti-roll and changing the characteristics have been used. Such studies have been published regularly. We have published 8 papers on that. I will give you the glimpse of those papers in next few slides. See, if you look at it, at the end, only 2 forces are playing around with it when it goes down and come back. One is drag, another one is lift. The drag force is mainly due to the hull form, the way in which the hull is there. Any object which is moving is experience an opposite force is the drag force, is a hull form force, hull form. Another one is the lift. Of course, there is a variation weight and buoyancy, and also the wing, the hydrodynamic lift it will generate. If I able to manipulate all these 3 things, I am able to control this one. So what are the things? One is nothing great things are there. Only is the hull form is there, another only wing is there. Where do I am going to place, how I am going to place, what kind of sections, how do I modify the small hull forms? All the things boil down to this, the lift and the drag coefficients. Once I have to put this into the lift and drag coefficients in the this one, then I find that the power required is directly proportional to the drag and the lift. If I want to increase this one, the operations, reduce the drag and lift, I can do it by changing the hull form and also changing the altitude also. The angle of attack also, I can change and play around and then do it. This is one part of it. So all specific energy consumption is related to drag versus the lift, a non-dimensional coefficient, drag by lift of the body. And the hull model can further modify to greater endurance and faster speed. I can play around the speed also there. So the blended wing hull form came into play in this case where the inherent hull characteristics conform to the above goal of achieving. When I want to study about the hydrodynamic forces and other things, I have to rely upon finding out the hydrodynamic coefficients. Nothing but if I have an equation, I have a coefficient. The coefficients, if I change and play, it will change the certain way the equations will going to be play. The equation is going to play around. So the forces on the glider as a function of hydrodynamic coefficient as shown in the equations. And all these things I am studying traditionally like an aircraft, unlike like a ship, where I measure the drag and the lift and then try to get the coefficients in the form of drag and the lift alone. And then I change the axis as per the axis of the one. So this is the way we have studied. And we did certain experiments both at IIT Delhi and IIT Madras, because IIT Delhi where we had the NCW and we have the applied mechanics department and we have the wind tunnel, and I worked there, so I could do certain analysis. The miring hull form has been taken. We have a wind tunnel of 1.6 into 75 into 45 centimeters the cross sections, and able to have a 25 meter per second of velocity. So we did the analysis there, and then this analysis have been used to validate the CFD model. And IIT Madras in the towing tank, both the hull forms, miring hull form and the blended wing hull forms, the drag and the lift characteristics have been studied for various speeds. The model which we have made it for the miring is almost I think 1:1, and for the miring is 1:3. For the I'm confusing, miring is 1:1 and the blended wing is 1:3. So we have to go at the highest speed to meet the Reynolds number criteria over the study. Okay, this is the model which we have manufactured. Not visible here. The model which is manufactured and the towing tank studies have been undertaken there. That is missing here. Okay. So systematic review of the published literature, whatever has happened there, review of dynamic turnings undertaken from the equation of motion has been studied. Some empirical, numerical and experimental study analysis were there, identified the gap areas. All those things have been published in a technical paper in the Journal of Small Crafts and Technology. It's a RENA publications, one of the RENA publication, and the part B2 in this we have published there. And this gives an insight. And the next study of the detailed study of the locations and the position of the wing and its effect on the drag and the lift characteristics have been elaborately studied both experimentally as well as on the numerically. And this we have published as this one. In the numerical study of effect of wing position on the autonomous underwater glider in the Defense Science Journal, and it is available on the net. And we have observed that there is no major changes have been observed with high angle of attack when with wherever I'm going to position it. But you can go back and have a look at the other 3 gliders, legacy glider, where they have positioned this. Almost it is aft, in the middle, almost in the middle, and almost all these aerofoil sections are all symmetric aerofoil sections, so that going down and coming back are almost symmetric. Then next study is that I want to keep the station keeping. What are the parameters of the glider or the hull form of the glider is going to do it? Station keeping is to do the spiral maneuvering. I have to move forward and take a turn, and I can only do is move forward and then take a turn. So for that, all the hydrodynamic parameters have been listed and then studied the sensitivity analysis of this. Each one hydrodynamic coefficients, what is going to have the effect on the radius of the curvature or the radius in which it is going to make a turn. This gives that lift coefficient on seeing that on the glider turning using rudder, lift coefficient increases does not result in any major change in the radius of the motion, whereas the drag coefficient increases. So I have to do certain nose shaping and the tail shaping to achieve the increase the drag at the same time if I want to do the station keeping of the mirroring hull form glider. Then again on the virtual mooring, I want this also called the virtual mooring. A review, we have done an analysis on the brief review of the development of design and processed a model for virtual mooring, and these are presented in the proceedings of the International Conference of Coastal and Inland Water System in 2019. Then when we are developing into the blended wing hull form, what happens when the glider is not having a wing? If I have a flat plate, then I have a knock-off profile, different knock-off profiles, and blended to it. Of course, the volume is a matter for the glider to be there to accommodate certain volume, and then study about the lift to drag coefficients. In the whichever is giving the lift to drag coefficient is giving the higher slope is better in the performance for the longitudinal motions. So that is the criteria which we look forward to look into the different design aspects of the glider. Then what happens when I give a sweep angle to this, a different sweep angle, and then do studies? When I do these studies, here also gives an important one that lift to drag ratio of these 5 models are plotted, and then it shows that there are certain possibility where the application is that I can choose the way in which the sweep angle can be given, where I can generate. Whichever is one having the greater slope is important, as I told, and lift to drag ratio plays an important role in the longitudinal motion of the vessels. These are the certain studies we have undertaken. Some more are on the wing shapes and the hull forms. And if you look at the research findings, we have the lift to drag ratio plays the sawtooth pattern, the motion of the vessels, identifying the important hydrodynamic coefficients which are useful for virtual mooring, sawtooth pattern or spiral motions have been identified. The span to wing ratio, span of the wing increases, L/D ratio increases. Symmetrical NACA is the one preferred for the blended wing hull form. Position of the wing along the depth, along the length of the glider do not show a variation in lift to drag ratios. Higher angle of attack is located better in the display of lift to drag, and certain algorithm which is identified to solve this kind of one has been identified. So number of publication looks we are in better. Now it is a time that we should go for getting into the production of the platform. This is me. I am trying to present this glider in Navy when I was in uniform on a Navy day to CNS House in his day, just before retirement 2015. Then it was shown in IFR also. Still some research are being continued. That thought I will stop, but it is not right without showing that other part of the one which I picked it up from net. The 12 robots that could make or break the oceans. One is the autonomous ships. A lot of things are being done. People call everything as autonomous ships, even if it is remotely operated vessels. They remotely operated with all the sensors. Then also they call it as autonomous. Autonomous meaning purely autonomous meaning it should be able to move freely by sensing itself and to go. It is going to take a long way where big data and then AI has come into play. But But the steps have been taken, people have proved, people are able to do to remotely operate the vehicles. Even a big ships can enter the port, leave the harbor without the assistance of the human, without the assistance of the human present on board. They are present, but they can remotely operate it. Such things have been shown in many of the one. Then another one is on the scuba diving. The operation can be undertaken by a robot. Then underwater augmented reality of the glasses where it can be there. Then the blue revolutions. As per the data on 2014, the first time in the world in which world ate more fish from farms rather than from seas. We have migrated. We have been once a long time back, ocean going fish we used to have a fix. Then we have migrated and a lot of farm culture happened on the land. Now this is the first time even in the sea, we make nets, have the nets there, and then have a culture there, and then have a farming. This happened, and many such firms are already come up. Personally, we are also doing a certain resistant test for fixing of nets into the oceans, and then within that you do the culture and then able to aquapods. These are all cages or aquapods which are coming into play. Innovations can be there. Undersea cloud computing. 95% of the internet or 99% of the internet traffic is transferred via cables, and you can have, and it's a quite good sync mechanism. Whatever the heat generated, it could be there, can be data could be there. Then new waves of ocean energy. After the war, they want to be away from the fossil fuel. A huge investment is happening on the energy generations on the oceans, waves, and on the wind installed in the oceans. A huge investment is happening, and we will see it in very near future. Within 2 years or that, many mega generators will be there available in that. Okay, ocean thermal energy is another aspect. Deep sea mining is another one. Ocean big data is another one, a field in which you can look at it. Then food, not only food, medicines from the sea is another one. Then you have got coastal sensors, sensing both. You are able to have a defense mechanism as well as rapidly warning system, even for tsunami, early warning and other things can be there. The coastal sensor. And the last one is biomimicking robots. This is taking into a shape where you want to repeat the mother nature, which says that efficiency is the maximum if you follow the mother nature. So you want to repeat that and have the biomimicking propulsion devices. A lot of research is being going on. I also showed you something. NRB is organizing something to make at least one prototype module on the biomimicking propulsion device. They are trying to make something similar to the bedkey fish, replica of that shape as a hull form, and then able to have it. With this, I give you a small glimpse of the underwater robotics. Any questions and other things, please?
Dr. Vijay, I have a question. This question is pending on my head from December.
Yeah, yes, sir.
There was a international convention on marine engineering held in Visakhapatnam, 2nd of December, which I happened to attend. So there are some small institutes who are working, in Chennai and in Kakinada, etc. There are some institutes. So they came and presented a paper. He is working on, first, my question is, you showed a composite propeller. Now, is composite propeller in use today in ships?
Yeah, yes, sir.
Where?
The figure which I showed, that was one composite propeller fitted on a Japanese, one of the Japanese vessel.
It's what, a merchant ship?
Merchant ships.
Okay,
Oh.
right. The second question is, he had a propeller which is impregnated with graphene. So, and he found that the thrust is much more, is a lot with that. So we get a good thrust with it. So he asked whether it could be used on, some submarines or ships or something. I didn't have an answer for that. So I told him, go and use it for a torpedo. Since I was sitting in Visakhapatnam, I said, and it still is here.
Yeah.
So you can have a look. Because it's very interesting, that paper, where you're getting good thrust
Yeah.
for small power. It's a power versus thrust thing. So, but I have not come across. We've used composite propellers for torpedoes, etc. I'm aware. That's why I told him. But definitely, I've not seen in any ships and thing. So that was one question I have think. But you are telling me there are some ships. Then
Yes.
why is it that we're still using the alloy propellers?
Why they are using? Why not composite?
Why are we not gone to composites? If you if you say that there is already in use.
Yes, sir. It's in the development stage. In the sense, one is that material is a composite. I can stitch the way I want. The way in which I want the strength, I can stitch it. The way in which I want to have flexibility, I can do it. The when you said that, sir, the efficiency is more, I give a certain kind of flexibility to the propeller. And the same size of the propeller, the weight of the composite propeller will be much lower than this. But the longevity of the propeller is a question mark. Yeah, long.
So that is exactly what why this thing was, because how many times we'll have to change a propeller because of that,
Ah.
because you say longevity,
Yes.
because this is a question which is pending in the domain.
Yes. Yes, sir.
That if you make a propeller like this, which has got graphene, because today a lot of people are working in composites.
Yes.
So this one was a new one which I saw with graphene in it, and the reason because the structure is there, which gives it that it's like using Kevlar or something, in a thing. So that was my question. That A, if it is good, where can it be used? Though I said torpedo, where can it be used? Two, if composites are good, why are we not switched to, say, ferries, small boats, etc.? Why haven't we gone to that yet? And why, as a nation, we can't do for inland transport thing? Why aren't we taking up for that? It's good to have, and you are a practical man. You've been in the Navy, you designed, etc. We have to get into the market, no? So
Yes.
So that was my question, because all the people will be here thinking that, okay, you've come and given a presentation, but where is it being used? Is it being used at all? What is the advantage you're getting by using it in the thing? So that is what also, that's why I asked you this question.
Yes. It's in the development stage. One is at present, until unless you make it in the mass more, the cost will not come down. So that is the first question. So my intention was that after retiring from Navy and then visiting beaches and the fishermen's, and then spending the time with certain time with the fishermen's, there are so many fishing boats are there. When I look at that propeller, which is small in size, not very complicated, and simple, and it is not designed to the hull and the boat. It has somebody designed, just fitted, running, efficiency is low. So my intention was to change the attitude there. So when I interacted and all, and they just believe in the mass of the propeller, the weight of the propeller. The moment they say, sir, it's something is tilted or turned or corroded or something has happened, I just take it, go to the vendor who is giving a propeller. Nothing is matched. Engine is not matched, propeller is not matched, hull is not matched, and we have plenty, thousands and thousands in number, and almost in similar sizes of the vessels itself. So they just go, give it to for a weight, and pick up that as another weight. So there has to be a change. It has to come. So we are working on that, sir. Maybe in few years.
Yeah.
I got few photographs in my WhatsApp. I'll just show it to you.
We are asking the fishermen to change their attitude. What
And,
about us? We have got the capability to design propeller, but there is no place where we are manufacturing propellers. When I say propellers, I'm talking for either the merchant marine or for the navy.
Yeah.
We still are importing propellers. So with having what is preventing, that's what I have not been able to see. We're able to design, we're able to analyze, we're able to this thing. Material I don't think is an issue, because you can develop your own alloy. I mean, we have got that thing also. We are making so many new alloys which are coming out of Midani or out of thing which we're using in space. I'm quite aware of that. So why is it that because that is the main thing, the characteristic of propeller will define a lot of things, especially for underwater objects. I'm talking of
Sir, can I take an analogy a little away and then come back? 15 years back, shipbuilding steel we were not having. Not that we were not having capacity, not that we were not having the metallurgy, not that this one. But the volume required was not meeting the commercial need. And there was a dictum somebody has imposed 15 years back. We will never go and get the steel from outside. Now we are in a state, all warship shipbuilding steel is indigenous. Similarly, there has to be a dictum for propeller. Not that we are actually manufacturing about 2 meter diameter of the propeller in India. Certain places in Chennai itself they are manufacturing, and then it's recorded. It's manufactured process. Yeah, the casting, we make castings without any defects of ideals of 5 meter diameters in brass. So that technology is also available. So it's only the willpower that this day onwards I want to manufacture propeller only in India. It will be manufactured. And apart from that, sir, I would like to quote here also. We have one faculty was come from did his PDF and come. He has made that and abroad they actually made a propeller of 2.5 meters in diameter by 3D printing. Different technology to print this kind of having a uniformity in that than having it. So he is also manufacturing a small impellers and other things of 1 to 1.5 less than 1 meter diameter. So if it could be scaled up, it could be. It is not difficult.
See, as you rightly or somebody said right in the beginning, we have all the brains, we have the
Yes.
technology, we have the understanding, but we don't do it. So my only question is, why are we still not doing it? Okay, when I was in the Navy, I fully agree that we were importing, and actually we didn't even. There is nobody here, even those who are in the dockyard. Once a thing gets chipped, what do? You ask. Yeah. So the question, no, we try and do something till
Yes,
the
Fitting.
ASW officer says I'm putting too much noise. So then we go and change the propeller. Otherwise, we think he also doesn't know. Correct? Dockyard mein. So the question is, propeller is very important. If you are making the whole ship, if you are making the whole thing in India, and it is like you said, steel. Right? I know the story of steel.
Yes, yes.
also,
That's
right?
why I took it.
Yeah, because I was very much there.
Yes.
It was made for something else and said you very well use it first. Okay, so it got used,
Yes.
right? But the question is, why? Okay, if somebody could do that for steel, why can't somebody do this for propeller? And every time we've been saying that we don't manufacture propellers, we don't manufacture. At least let's start manufacturing for all the other thing, inland border transport, this, that, etc. Start making the propellers, then you know, say, there's a propeller manufacturing company and thing. Then maybe we can look at. So
Sure,
it's
sir.
important to, and I'm only worried about much later is underwater propellers. You know, I'm talking the submarine, but that is another thing which we'll only get to there if we move these steps.
Sure, sir.
Good afternoon, sir. I'm Deputy Commandant Samir. My question is related to the drag reduction technology that you were mentioning using the bubbles.
Yeah.
So my question is, are there any ships actually using this technology? And if
Yeah. It is there.
if yes, what is the difference in terms of speed that we gain using this technology?
I'd say more than the speed it is gained, it is more than the fuel it is consumed. They look at it in that form. So one of the cement carrier, which has got a lot of generation of the air and other things for pumping out and cleaning and other purpose. So they are using this for the bubble induced drag reductions. Now it is getting popular and these bubbles are there. People are gone into even micro bubble and other things. I am not getting into the micro bubble, just air injected this one and then able to generate. The thumb rule is that it should be a flat bottom vessel. Bottom should be flat. Then what we in our research we have found out is that if we inject the bubble and that flat bottom, 80% of the bottom is covered with the air bubble, it will cover if you go at certain altitude. Then you will have more than 6 to 7% reduction in the power. So you have to produce the bubble and then pump it inside. So we have done the economic analysis and published a paper in the this one, SLAMI, US journal paper, which talks about all these things. So anything less than that is not that advantageous. But 80% if you're able to cover it, it is quite good advantages. You have to maintain the altitude and other thing for that.
Sir, and if we are using the bubbles and after a certain point of time, those bubbles will split. So will we not have a cavitation effect in the hull of the?
Yeah. In fact, one of the papers is what is cavitation? We have to understand. Cavitation is the formation of water molecules into water vapor. Water molecules into a water vapor. So how does it water vapor, like in the pressure cooker, you have got a high pressure. Even at a very low pressures, at low temperature, it can bubble and form. That is what cavitation in the fuel. So the front and back of the blade, from the back of the blade, where a negative pressure is generated to give the thrust. Negative pressure is generated to give the thrust. That negative pressure is so low, a cavity is formed. Water is become water vapor and then stick into the propeller, and then it doesn't explode. It implodes. It collapses. It implodes. When it implodes, it's eat away the material. Okay, this is two different things. Medium is different, and it can be a nucleus. This air bubble can be a nucleus to generate a cavity. So the cavity. So that we have to read it in little more in depth to understand. So it is not that cavitation is a air is being formed. It is a water going into water vapor, getting attached to it, and then implodes. Rather than air, which is the aerated water. Aerated water could be a nucleus to generate. But certain literatures, when we are reading it and finding out, it is not creating. In fact, it is better for it. So we have to do a research on this topic. So that is why I don't give this idea to the warships. When it comes to the bubble-induced drag reduction, it reduces the frictional resistance, not the wave-making resistance. The frictional resistance are high in slow-speed vessels. Slow-speed vessels are oil tankers, then not even container vessels. So commercial applications are much more for air-induced lubrication compared to a high-speed vessel. High-speed vessels, we have other alternatives where we induce a vane, where we induce a flap, all those things. We have done it for one vessel. A lot of commercial people are approaching us to induce that. We are only not responding because their restrictions are too many. So we are not responding to them. Otherwise, for a high-speed vessel, different applications. Low-speed vessel, different application. Medium-speed vessel, different application. We are attaching, looking into these three little differently on the green ship initiative.
Thank you, sir. So I just had a question regarding this communication thing. You brought out the communication. I mean, still, but the mode of communication that you brought out was basically the satellite communication. So is there like, fine, with regard to gliders, it's a satellite communication. With regard to, tethered web, they're saying if it's having a cable, then absolutely there's no issue. But what about AUVs? I mean, AUVs with any of the submarines, is there any other mode of communication apart from satellite communication for communicating between the AUV and the submarines?
I think Arnab can answer.
So anything underwater has to be acoustic communication. There is no other way. So if you have to do satellite, it is RF, right? So for that, you have to be outside the water. So what he mentioned is that it comes out on the surface, and also you may need a height. So either an antenna goes up or even the body goes up to make sure that the antenna is on top. But anything underwater has to be acoustic communication. So there are modems, but once it is the signal is acoustic, but rest of the things of coding and all those things are very common to any communication system. Anything actually in nature is not digital at all. Anything in nature is analog. So that analog signal could be acoustic, it could be EM or whatever it is. But it is only when you sense it and then you convert it to digital. After that, it is like any other signal that you are dealing with. So in underwater, it has to be acoustic. So accordingly, you have to have an acoustic sensor both for transmission and reception.
Yes, sir. Basically, that is what my question was. Okay, apart from acoustics, maybe if there is any other source of communication which is...
No, see, the biggest problem in underwater is the attenuation. It can only handle, the underwater a channel supports acoustic only because it has to, the acoustic range is 20 hertz to 20 kilohertz, right? And in underwater, it is a band limited channel. When we say band limited, the upper limit is decided by the frequency which gets attenuated. Higher frequencies get attenuated underwater. The lower frequency is determined by the size of the transducer itself. So you can't, the motivation would be to transmit as low as possible. But antenna will not support that. So that's why we call underwater channels a band limited channel. Very low frequency of 100 hertz or something can travel thousands of kilometers. But you can't generate that kind of, at least in the transmission mode. Reception is still okay. So that is the limitation. Any other form will not last, or they will. And there's a relation between the resolution and the frequency. Very high frequency will give you very high resolution, but it will not have long range.
Sir, my question whilst I have seen that a lot of focus is there on AUVs and autonomous underwater vessels, is there enough focus on tethered drones and tethered vessels? Because I see that they have a greater chance of success and lesser cost towards development, because we do save on communication aspects and faster data communication rates across these vessels. And is it that India has moved across this and directly transgressing into the autonomous part, or we do not require to now go to the tethered aspect?
I think tethered one, as per the need and the scientific need, whoever is doing the research, they are making on their one and then deploying it. Gave a list of 6 in number of examples of the AUVs and the tethered one used by NAOT. And tethered one, even with the one, it is being developed. AUV is little more challengeable compared to tethered one. So we are slowly progressing from the tethered to AUVs and furthermore into group of.
There is also one angle of, depends on the application. See, what you said, ROV, if you have to go very deep, managing the whole tethered cord itself is not easy. As exhausters, you'll appreciate. Maneuverability underwater, because the weight itself becomes very difficult. So, but certain applications we require, so the tethered part is called an ROV.
Yes.
And otherwise it's AUV. But ROV has certain limitations and certain advantages also. But if you have to reach very far, then it is very difficult to have a long cable. It will have many other maneuverability issues in terms of managing that.
No, if your power is on top, your communication is on top, you can really control it. Wherever such application is, that ROV is used.
What I wanted to say is that, are we focusing enough on tethered? Because close to coast applications of tethered drones or tethered ROVs are much more, and we are likely to experience greater success in my opinion, towards tethered ROVs. So is it that we are directly trying to go towards AUVs and not focusing enough on tethered drones? Is what I want.
No, I don't think so.
Same thing. I also don't think so. Application or
long back, I think we were also very concentrating on ROVs, wanting to get ROVs onto our platforms, etc. But you're right, the focus seems to be AUVs. I don't hear about anything about ROVs. Is it because of the handling equipment? That's a question we need to ask ourselves. Anything towed, anything thing has got different issues, seamanship, there's that recovery. So I have noticed that everywhere we have shifted from towed to, if something can do it on its own and give me the job, I don't want to tow it. So I think more it is on that. While towed cannot go far, all that I can agree with you. But there are requirements for ROV, and why don't we have ROVs? It's a good question. So I have a feeling from my experience and thing, whatever towed we had, we have done away with. Whether it was a towed, buoy, towed noisemaker, towed, sonar, long back. I'm talking of not the towed array, but towed sonar we had, or hull variable depth sonar, which we had from the Russian ships, and ours also on the Leanders we had. And later we gave up. And everywhere the problem was handling, because of the handling, maintenance of the handling equipment, right, etc. But instead of finding solutions for that, we abandoned it and we started going elsewhere. So actually it depends on the need, as he said. If it is required, I think we have adequate this thing, especially in the for the towed machinery. I'm forgetting. Sorry, that I think we have. See, when anything gets towed, right, it cannot be a rope. It has to be fair for a while and then sink. So those things, we have stopped working on it. I know that we were working at one time, we produced, but then the requirement from the Navy itself changed. So if there is a thing, it can be done. In areas like he's talking, I know about told thing being used by NIOT for a lot of application, but then that is research. We are looking at operations, etc. Am I right? We're looking at operation. So if the need is there, it can be got. Otherwise, thing. And at the same time, I don't know very many toad. Toad means like ROV, being used now. Earlier, ROVs, big fellows used to be on the side of the ship like a boat. I've seen not in our ships, but in the other Western ships, which thing. And at one time, we were also planning to. When I was young in the Navy was planning to look into it, but for some reason we dropped it. So I don't know. It could be one, I believe, handling, because anything that we handle has a risk in terms of maintenance, in terms of when bringing it up back, because for some while it'll come back. After that, we'll tow it and bring it back. Did we probably that will be the thing, or is it there is no requirement, or automatic AUVs meet your requirement? Then why should you go for anything that is stored? So that also is a thing that needs to be looked at. But so unless there is a need, the further research into thing, I think will not happen. So that is the.
Okay, I had put two questions on the chat box, post, but.
Can please read out your question, sir?
No, that's okay. That you will see eventually because it will chat box. But what I want to ask now is something different. Now we are talking about the cavitation and the effect of producing water bubbles for to reduce the hull friction. Now, I want to ask whether these are two different situations, because in the case of cavitation, the bubble formation is by the evaporation of the water, and when the bubble implodes, almost perfect vacuum is produced, and that creates a high velocity water flow. And when that hits the hull, it produces erosion. This is what I have understood about cavitation. But whereas in the other case, the bubble is produced by the air. And when that bubble collapses, does it produce a vacuum? Then only it can create a erosion or cavitation. Now, am I clear?
Yeah. Is it a question or it is a remark?
Yeah. So my question is this bubble formation for the reducing the hull friction, can it result in cavitation?
Yeah. See, in this bubble, actually we are sending high pressure air or little more pressure than whatever the pressure which is being experienced at that locations. Then only it will be able to pass through it. When the bubble passes through it or the air passes through it, it splits, it coalesces, it forms a bigger dynamics, and then bubble itself will form into a different layers, and it is buoyant, unlike other things. And then because it is buoyant, it will come on top. When it's coming on top, it sticks to the hull. So this dynamics itself is completely different from the way we are looking at the cavity formations. It is not a cavity, it is a bubble. It is filled with the bubble. It doesn't, I don't think so, it implodes or explodes. It forms and coalesces and forms its own dynamics differently. So this itself is another big study which people are doing. And then erosion because of this, I don't think so. Maybe corrosion happens because of the air bubble is there, but I don't think so erosion happens. That is what the literatures and the published one is giving an answer, sir. So I also go along with the statement what you made.
Thank you. Now the questions I put in the chat box.
Yeah.
Can I read it now? Or
yeah, please.
Okay. Now you mentioned that the sweep angle,
yes.
the effect of changing the sweep angle. You made some researches. Now this change of angles was done in the same model with the arrangement to change the angle, or you used a different models, and because how costly is the model? That's the basic reason for the asking question.
So the sweep angle on the same, meaning the one what I presented was only the numerical study, not the
okay. Not. Oh, I understand. Okay, so sorry. Okay. And my second question was, in the gliding, like kite, for example, the propulsion power is produced by the movement of air or water. If it's underwater, it's the movement of the water, right?
Yeah,
But
yeah.
for maneuvering the glider, you need to change the certain changes you have to make. And in a paragliding, the person makes the changes. So, yeah. So how do you do that in the case of a model?
Or the model or the actual?
It's the actual model, right?
No, yeah, actual, how does it do is by two ways. One is the rudder. Another one is the weight, changing the weight. When I want to change the altitude of the vessel, I used to change the mass which is the heavy mass which I have a battery. I loaded the battery in such a way that I can change the mass, by changing the mass, I change my center of gravity and the center of gravity. So by giving that, I'm able to change, and also it can roll. It's a different mechanism for the gliders. The whole weight can be rolled to one direction to change the altitude, both in the forward direction, that is the pitch, as well as on the roll direction, so that I'm able to change that and then able to attain that and have the altitude change in the this one. So these two has to be performed simultaneously. Rudder is the most effective one, and this also people use that. Even for minor corrections on the altitude, the change of weight is being done inside the.
Okay, I understood that. But how do you make the changes? By remote control?
No, it has to sense. We have made small changes. The model which you have shown, it has to be able to sense. I want to maintain a 35-degree, or when it is going to ascend, this angle should be maintained. I should not change the this one. It will be able to sense and change the weight.
Okay. Thanks a lot. Thank you.
Okay.
Thank you, sir. So I have done one research paper on biomimetics, and this is actually a basic doubt, but it's been plaguing me from the very beginning of that research. Thing is that, for example, let me just give an analogy. In the 1950s, the US, in the 1950s, the US decided to make one submarine. It was, again, I forgot its name. I forgot its name. Like I did this paper 1 year ago. So I just searched it up, but still I couldn't find it. The main problem was that it was actually the biggest submarine till then in the US, in the hands of US Navy. The problem was that they used the biomimetics for for the designing of the hull of the submarine, and the animal which they copied this was from the dolphin. Still, it showed some problems with the maneuvering abilities and all, because of the copying mechanism, like the way they copied it, it went horribly wrong. And this actually led to one more paradox again in the field of biomimetics, which was a subject of debate till 1970s and 80s, until the MIT scientists proved it wrong, that the paradox itself is wrong innately, and it ended. But still, my doubt is that, for example, for the time being, let us consider two different organisms. One is Minkley, and the another one is Prestidae. Or in simple terms, it is a cichlid. Minkley is a cichlid, and Prestidae is a sawfish. Both of them uses stealth for very different purposes in their life cycle. This cichlid uses stealth for mating, and Prestidae, the sawfish, uses stealth for hunting purposes. So how does we overcome this confusion when we are choosing an organism for our design? Like both of them, like if you are you can just search in the internet for their pictures, and you can see a widely different organism. Both of them are widely different in their body functions, in their body structure, in their morphology. So when we are suppose you are designing one submarine, and you wanted it to have the maximum stealth, and you are actually trying to follow the path of biomimetics. So how can we overcome this confusion that persists there?
So you are looking at the stealth or the propulsion? Okay. See, the propulsion by biomimicking, I don't think so submarine exists. Okay. It's a very, even though it has been started a long time back, the success or it's still in the nascent stage because we are not able to mimic the fish as a whole. Some of the fishes having a flap like this, whereas whales have a flap like this. It's a different configurations and other things. And the propulsion device is not only the fin, the way in which you are looking at it. The whole body itself is a propulsion. They adjust the buoyancy. They got a fins of different caudal fins and other fins to adjust the stability, and the whole body moves. It's all into the form. So now we are in a stage where we will use a flap as a one is flap as a propulsion device, and then even in the flap, the flexibility in the flap is introduced. Now it was a fixed flap with a rigid flap. The flexibility in the flap, then not only the flexibility in flap, we will have two different layers of that. Then people have studied even furthermore. When the flap flaps, the flow pattern around the flap is a vortex. Vortex is generated. What is a vortex? Vortex takes away energy from the flap and go. But the same vortex is providing the thrust. Vortex is the movement of water in a direction. So they have found out it is not the vortex assist. It is a reverse one common vortex. Assist to give a thrust in the front. So that happens in certain Strouhal number. That also identified. So if you operate on certain Strouhal number to produce the reverse one common vortex, if the flap is able to create, then you will have a positive advantage of giving a forward thrust. So we are working, meaning the team is now, the whole world is working within that Strouhal numbers to give that reverse one common vortex so that flow pattern assists the forward thrust. So it is still a lot of study and other thing is going on. Smaller and smaller objects are mimicking the biomimicking propulsor, not the big submarines, not the big ships with the flaps. Even I have showed one small videos where flaps are there. When the flaps moves, vessels moves in front. It will take long time to come into that and this one. But smaller objects, I want to stay longer, use less power, more efficient. Then still I can do it and then go for it. Efficiency is the only thing. Your question is, do I have this stealth or other stealth, this propulsion or other propulsions?
Okay, sir. Yes.
Where do I get the maximum efficiency? One number I told you was Strouhal numbers, where I want to use the science of producing reverse one common vortex to give a forward thrust. If I operate within that, whether a flap is like this or flap is like this, if I'm able to do that, I am in an advantage. Where my propeller is 60 to 67%, if I increase to another 6%, 70, 73%, I can stay longer. That is the only thing, and that is the main. All the objective of any research is that how do I activate to get a better, efficient propulsion device.
Sir, but in the case of submarines and all, I mean, literally in the case of warfare, when we are coming, we cannot always depend upon the we cannot always focus on the propulsion efficiency. Like stealth is also an important factor.
Yeah, stealth. So it is still there. This is more still there.
Yes, sir.
You have a fixed machine rotating and creating so much of noise. A flap rotating at a very low Strouhal numbers, move forward and come back. You don't make so much of noise.
Sir, like I just give this an example, only. I'm not asking about stealth, particularly on stealth. For the, like this is an example, and this is a just basic question, sir. Not about the biomimetic, not about the propulsion or the maneuverability, nothing like that. It is a basic question, like how will we overcome the confusion of selecting which animal on the designing part? That's my only question. Like
proper literature review before you are having within your objective of project or this on research objective, and proper literature review, technical review will give a conclusions on the gap area and arriving at fitting yourself into the research domain. Yeah,
that was, I think, a very good question. But if you remember yesterday, Venkat was mentioning about, a clone if you have to make. See, finally, you have to understand the whole dynamics of that particular animal, how, or for biomimicry, you have to understand every aspect of it, how they are doing it. And till very recently, we did not have the computational power. See, finally, it's modeling and simulation, right? You have to understand, as Vijay said, you have to do a lot of models and then simulate and understand various aspects. But now I think we have reached a level where we have a reasonable amount of computational ability to really model something to as much accuracy as we desire. And as Vijay also said, there are so many questions to be answered. right? I mean, what are you trying to learn from that? So to learn, you have to first be able to clone the same thing, and you have to be able to do simulations with every possible representation of the animal behavior. And we really did not have the kind of computational capabilities. It is getting better and better now, but I think it will still take a long time, as Vijay said, to really understand. And also, when you do something, you have to have your research question very clear. What are you trying to achieve? And it has to be multidisciplinary. A lot of modeling and simulation will have different perspective, different research questions that need to be answered. So, but I think it will, I mean, as he said, it's an effort of so many different researchers over a period of time, and slowly we are maturing. But I think it still has some distance to cover.
I will simplify this in a small nutshell and answer. So if you are doing a prototype and the model scale test anything, we follow 3 laws of similarity. Okay, this is dimensional similarity, then dynamic similarity and kinematic similarity. But you cannot meet all the 3 in most of the time. Even today, when I want to do a model testing of a ship, I cannot meet on the dynamic case. Reynolds number similarity, I cannot meet. Then we evolve a method. Still, we are designing. We are having a propulsion device, fixing the main engines and the propeller. Understood, no? So this we would have studied in second year of BTech. Laws of similarity. This we have to follow. And it goes, dimension goes bigger and bigger as you go more similar to the cloning.
Okay, I think we'll break for lunch. Vijay, thank you so much.
It's
we have not only been able to engage for the time, but beyond. And I think there would be many more questions. You may like to talk to Vijay during lunchtime, and otherwise you can always send a question to us and we'll reach out to Vijay to answer. It was very thought-provoking, Vijay. Thank you so much. And you really covered a wide spectrum of issues, and you represent the hydrodynamic community and the naval architecture community, so which is very important when we talk about the underwater domain. So thank you so much, Vijay.
Thanks. Thank you, sir.
Okay, welcome back. Let us look at the UDA framework as such in the larger global perspective, how it has evolved over the last 100 years, and some of our interactions now, both at the national level and at the global level. Now, if you look at the larger UDA initiative, it was in the Cold War period, after the Second World War, when the entire global community was divided into the 2 superpowers, right? That time the requirement was that they wanted to engage their adversary as far away from their territory as possible. So between the Americans and the Russians, it was the Greenland, Iceland, UK gap, which became the theater of operation. Submarines had started emerging at that point. So underwater domain awareness became a very, very important requirement. So one of the biggest investment at that time was the social system, sound surveillance system that was off the Bahamas, right? What was it? It was basically a underwater sensor network. It was a highly top secret project. You have to look at it from all the 3 dimensions: political, economic, and military dimension. What was the political dimension? We were at war. So as far as strategic security is concerned, there is no questions asked. The political leadership could approve any project in the name of national security. Are you with me on this? Neither environmental questions are asked, nor economic questions, or the funding. Now, if you look at the whole American and the Russian system, that was the time they spent almost infinite amount of resources for military technology. Later on, all these things were available. I mean, like Kaware Talwelkar also mentioned, the internet is all because of the military requirement. Your gas turbines, aviation came because of military requirement. So a lot of investments happen, and you must also keep into account that during the Second World War, the Americans made tons of money because of their unique positioning geostrategically and geopolitically at that time. And they developed that military industry complex at that time. And after the war, when they did not require enough people for the military, these people went on to build their military industry. And the whole economy is based on that. But then they started putting in so much of money. If you remember, towards the end of the Cold War, it was just about who blinks first. If the Russians could have withstood for a little longer, Americans would have fallen, because they had become completely bankrupt. So during the Cold War, a couple of very important things happened. Soyuz was the beginning of a large, it came out about in 1948, it started, right? And there was another infrastructure called the Point Sur Lighthouse, which was basically an underwater lab set up by Naval Postgraduate School, Mandar. It was a complete underwater lab that they had set up in the Californian coast, and they used to do all kinds of testing there. The Soyuz was the beginning of the entire underwater sensor network project that started, and later on they had almost 30 such stations. The names kept on changing, but they had almost 30 stations like that across various locations. But slowly they started. So initially, Soyuz was a completely top secret. Even some people in the Navy didn't know that such a facility existed. It was that kind of top secret project. But in the mid 60s, there was a very funny incident that happened. One of the captains on duty there, he reported eerie sound coming out of the system. So they called somebody called Roger Pine, who was a marine biologist, to come and give some advice. That's the first time they called somebody from outside. He was in the university. Roger Pine investigated this and found out that it was humpback whale sound. Humpback whale is a very unique creature. I mean, the whales have, very well-structured notes of sound that they generate. And they sing the males sing for the females 30 minutes or even an hour. So inadvertently, they involved him, and he sold 30 million copies of that recording. And this is the first time, which is the other side of underwater domain awareness. They realized, what kind of sound. So this became a very big asset in terms of, and you imagine 24 hours, 24/7, this data getting recorded. But they did not have the bandwidth to analyze the data. Data was just coming. Even Soyuz data is available today also for analysis, and 90% has not been analyzed completely. It was only case-to-case basis, so we want to analyze this. But when data is coming, we can analyze it and of course, there was computational power was also not available then. And they started setting up, so this was one aspect of it. The second part is, then sometime in 1984, the Point Sur facility had to be shut down. They have given multiple reasons, but it became economically unviable to actually maintain a facility, exclusive facility like that. And it had to be shut down. Soyuz, towards the end, there was no upgradation possible. So towards the early 80s, out of 30 that was there during the peak of 60s, it came down to 3 functional facilities. Because these things cost money. The other aspect is, after the Cold War ended, in 1991, the first thing that happened was the environmentalists also started getting heavy on the US Navy. In 1994, there was an incident in the coast of Greece, Caprioska beach. There were 17 beaked whale strandings. The people tried to push back, but still 7 of them died on the beach. And this becomes a very big focusing event. There's a public opinion that gets created. So there was a Greek marine biologist called Antonio Francis. He wrote a paper in Nature after a year that this stranding was because of sonar trials by the NATO forces. This was a sonar developed by the US Navy being tested on a NATO ship off the coast of Caprioska. And this became a major focusing event. Focusing event is an event which creates a significant amount of public opinion that the political leadership is forced to take action. So this was one of the major focusing event in terms of underwater noise. NRDC went to court. NRDC, an NGO in the US, they went to court and they forced the US Navy. They were obviously gunning for a complete ban on such sonar trials, but they could manage to get significant funding for research. The American president had to use his special powers to avoid any ban on sonar trials. You just see the period, it was post-Cold War. The whole political climate was different. You understand what I'm saying? So that is what we need to understand. Politics becomes, we had a lecture by Professor Anamika Barua on the first day of the first workshop. And she talked about, there is always, there is nothing like economics. There's always a political economy. So politics of the time will have a major bearing on decision making also. The American Navy had to be very cautious. The other event was the Surtas LFA, low frequency active. This was another system the American Navy had developed for monitoring. After the Soyuz, it came down to Surtas and then it became towed array. So they used to use active frequency, low frequency active. They used to keep the whole area illuminated so that if there is any intrusion by the Russian submarines in the region, they would get. Surtas LFA was forced to submit an environment impact statement in 94. Can you imagine the US Navy being forced to submit an environment impact statement? And that is the beginning of a monitoring by the environmental scopes. There was another system called ATOC, acoustic thermometry of the ocean. This was a low frequency system developed by the US Navy. They first deployed it they had a different name earlier, and then they deployed in the Hawaii region. When you use very low frequency, you can detect up to thousands of kilometers. The real reason, as many of us understand, is any monitoring, any underwater monitoring. But what this tried to tell the world is to basically detect global warming. Because underwater sound is very sensitive to the temperature, right? As I said, 1 degree centigrade change makes 4.6 meters per second difference in the sound speed. But this is extremely harmful for marine mammals, marine creatures. If you constantly subject them to radiation, what are you doing? So ATOC also had to be slowly withdrawn after a point of time. So that was the changing scenario in terms of, understanding. So when we were proposing the underwater domain awareness framework, our effort is to bring all the stakeholders together, and particularly when you talk about democracies, the political leadership in a democracy has to balance a lot of socio-economic and socio-cultural and socio-political also factors. to say that strategic security needs, I mean, that's why, in India, also in many other countries, sometimes it is a very frustrating effort for the naval leadership to get a certain projects passed. Because the leadership has to balance various other things. Because it's a democracy. Next time they have to get elected. The same case in the US also. That's also a democracy. So as a political scientist, you have to understand the whole crux of the dynamics of the present era. Now, after the Cold War ended, in a decade's time, the American establishment realized that the Chinese have developed significant underwater capabilities in terms of submarines and other things. And now they have to have a presence in the South China Sea. So in 2000, University of Washington and 5 other universities of the US were asked by the Office of Naval Research to develop capabilities in the South China Sea and East China Sea. Because if the American establishment comes down, then it will create a lot of diplomatic backlash. So University of Washington and 5 other universities in the US got together to plan the entire modeling and simulation in South China Sea and East China Sea. Because they had no idea before that. And as I said, the tropical waters are different. So they took some time, and then what they initiated what is called an Asia X. You can Google Asia X. Asia X took more than 3 years or 4 years of data collection in the South China Sea. So in the first phase, these 6 universities got together to do the entire modeling. But when they had to do the field validation of the model, they needed local support. So altogether, 20 universities, including these 6 universities, came together to start what is called Asia X. They collected data for more than 4 years. Again, the problem of computational infrastructure, computational backing, they could not really do the analysis of the entire thing, but there is a lot of data. Even 2006, when I was in IIT Delhi, James Miller and various other, Peter Dahl and all these guys had come down from US to meet us, and they wanted data analytics support. 2019, I was in Brest in France. University of Brest, the French have sensors in the Central Indian Ocean. The French have the maximum EZ in the Indian Ocean. How many of you know this? Right? So, but they have these sensors, they're collecting data. They say they are monitoring marine mammals. University of Brest is tasked to do the data analytics. So I met the folks there, and they needed help in terms of data analytics. They don't have people, they don't have the kind of intelligentsia that our people have. So what I realized is that the global community needs significant amount of support from India, even for these kind of efforts. It is easy to collect data. You can put sensor data, and once you put sensors, 24/7 data will keep coming. And it makes no sense to collect data like that. The best way is you have a plan, you go out, collect data, come back and analyze. You know what are the mistakes you have done in terms of the planning of the entire design of data collection. There are various places, ways you can go wrong. And once you have sorted that out, then you go again for data collection. Otherwise, there's tons of data they have collected and they don't know what to do with it. And of course, between 2003 or 4 to now, what kind of computational advancements we have. AI is a 10-year-old or 15-year-old phenomena, right? Deep learning is even lesser than that. And now we are talking about quantum computing and a whole lot of other things. So what I'm trying to say is that we are in a better time now. We don't have to exactly do what they have done, but we can do something better than that. We have lessons to learn from what they have done and where they have gone wrong. But we also have the advantage of the excellent human resource that we have. We can put thousands of engineers with a specific problem and they can give us good amount of returns that we want, and the entire UDA can be looked at in a very different way. So Asia X itself was another big UDA initiative in the South China Sea. Now you look at the Chinese perspective. Asia X, we had multiple Chinese universities which have participated in Asia X. I've interacted with few of them. I was in 2016, I had attended Oceans for the first time. First time mainland China hosted Oceans. Ocean is the biggest underwater conference that happens in the world. Once a year it is in US and once a year it is outside of US. Last year we hosted in India, Oceans, first time. So in 2016, Shanghai hosted Oceans and I was there. Two very interesting interactions I had. I went around asking people, why did you participate in Asia X? The Chinese were very clear. In 2000, we did not have the capability to do an experiment of this size. So we wanted to learn. It was not that they didn't know that Americans are here to collect data. And if you look at it, so many Chinese naval officers and their DRDO equivalent, they have gone to University of Washington to get their master's and PhD. But they have a very clear brief to go and come back and contribute. They are sponsored by the government. They come back and set up things here. In 2015, China announced what is called an underwater Great Wall project. And what was underwater Great Wall project? It was something similar to Point Sur in California. And if you look at what they announced in 2015, that is an effort of minimum 20-25 years. So they had embarked on a plan way back. And they had been developing. And in fact, when I was in Singapore in 2015-16, they were very regularly interacting with our lab to set up a complete underwater lab. I mean, the Great Wall was a work in progress, but they had achieved a lot of capabilities. And they were open to collaboration. But till 2015, they did not speak a word. 2016, when President Trump, look at the sequence of events. When President Trump was a president-elect, those 20 days, China had captured a US drone deployed by USS Bowditch. They captured it, kept it for 3 days and returned it. Capturing a drone is actually an infringement into the sovereignty. Right? I mean, naval officers know this. And Trump, as a president-elect, he was not president, he was president-elect, he had to break silence and speak. He used this exact word, infringement on the American sovereignty. And the Chinese just said, he released it. And that was a declaration that, and yes, after that Asia X in 2003-04, Americans adopted underwater drones as a regular part of the American Navy operations. And every cruise in the South China Sea and East China Sea, because after Asia X, they needed continuous data flow to keep on updating their models and the validation. And the Chinese were fully aware of it. So they wanted to tell in 2015, once they had declared underwater Great Wall project, and that was a change in the whole geopolitical scenario. China was no more emerging, it had emerged. And if you remember, after 2016, all this talk about freedom of navigation and all that started, it became very aggressive. So there is a continuous link of UDA capabilities. And China has gone in multiple ways. They deploy fishing fleets of the size of 300, 400, up to 500 fishing boats. A carrier battle group cannot cross that, right? So they have developed various other, and they had a massive restructuring of the armed forces some 20 years back, right? And all the people were laterally shifted to these places. I mean, their fishing boats are not like fishing boats. They are far more capable. Not only in terms of their endurance, but even in terms of what they carry. So there is a complete chain of events which we must understand. But I am not aware of something like Asia X. It's called a swamp, shallow water measurement, acoustic measurement exercise. We need swarms in the Indian Ocean region. It has to be of a scale that can give you data of some relevance. And that cannot be done without the support of the big powers. Because we don't have the ability to do it at a scale which they have done. So that is the larger journey. Somehow, we have not invested in the kind of modeling. See, you cannot, many times I have seen, I don't want to name organizations, that if the user says, I want X, they said, give me data. But can you collect data like that? Actual real data is supposed to be used for validation. I have a model. Look, I showed you that underwater radiated noise, spatiotemporal map that I showed you for the entire Indian Ocean region. Can you collect, and it is a spatiotemporal. Spatially, can you collect data in every point? Temporally, can you collect data of all the points? How do you do it? You make a model, you test the model on those critical points. And if that model is fine, then you have faith in this model. So you give a certain confidence level on this model. And then for anything, whether it is a naval deployment or any non-naval deployment, you can use it. Suppose maybe your Coast Guard says, the top commander says that we need to deploy assets in X location. Sitting here, your system should tell you what is the condition in that location. Or if you say, we are planning for a deployment after 3 months or 2 months or whatever, your system should be able to give you, your model should be able to run and tell you what will be the situation then. And based on that, plus minus a little bit, you plan. Today, even for sonar trials, we don't know what we are doing. Even to plan, I mean, there's a technical officer here. If you have X sonar to be tried, before you plan the trial, don't you think we must find out what will be the condition and what is the predicted performance? And plus minus, that is acceptable. But we have no plan only, because we don't have the tool for that plan. But the sonar performance, as we know in the tropical conditions, will have a huge variation depending on the conditions. Do we have a system where we take into account all the possible conditions? So based on this, we make a plan. And what is required for sonar trial? SNR data and channel model. Y of n is equal to x of n convolution h of n plus w of n. That's a simple formula. So if you can predict w of n and you can predict h of n, x of n is known. So what is the spectrum of y of n we need to establish? If we can do that, we are doing well. Otherwise, we go out. To sail a ship is not a joke. To sail a submarine is not a joke. I mean, my ex-officer friends will know, bear with me. It takes so much. I mean, there are plans already there. If you have to deviate from that plan, it is so very difficult for my operational plan. And you are not prepared for that deviation. You're going blind. Cannot happen like that. Even for any other purpose also, whether it is environment, forget, I'm not talking about Navy here, I'm no more part of the Navy, but I'm saying even for an environmental monitoring exercise, if you have to go out, don't you think you need to know what are you going to encounter there? And it is easy to do in today's world. Real-time computations are easily available. Nowadays, you don't have to buy supercomputers at all. You can hire computational. My team does not, they go on the cloud and do the computation. So it's very much easy, that's what I'm saying. But of course, if it is a strategic requirement, you cannot use that. For that, you can spend money. I mean, to have a dedicated thing, and for that, I don't think we have shortage of resources. But for proving the concept for an organization like us, we do it like that. And the ecosystem provides you for that. Like even Venkat said, you can go on the cloud and do even quantum. And for that also, you don't need any specialization. If you know Python, you can do that. Python is known by every youngster in the college knows Python. So today the tools are available. You have to just know how to use it. More than even that is not required. You have to know what you want. If you know what you want, how to do it is possible. So the larger picture is now going forward. Whatever I could envisage. One is, I feel there's a disconnect between user, academia, industry, right? So the National Skill Development Corporation, NSDC, has this thing of sector skill councils. So we have proposed for setting up a sector skill council on the underwater domain awareness framework. This brings all the industry together. So we have been backed by the Maratha Chamber in Pune, and now it has gone to FICCI, to the NSDC. In fact, this time we were supposed to have the CEO of the NSDC, but he could not attend but at least he's aware of us. And I'm also part of the FICCI task force, so we are going to push it from there also. But now I think we have a convincing enough case, but it has to go through their process. And at a certain level, there is a reasonable coherence that such a thing is required. Even just to support the Sagar vision of the Honorable Prime Minister also, it is very much part of that whole thing. And because now why NSDC is important? Because they have a complete, there is no point creating new instruments. There are already enough instruments in the whole governance mechanism. You just need to pick up the right instrument and make them come together, or connect those modules. Because government is also looking at now exporting skilling and knowledge to the region. So NSDC already has certain mechanisms of reaching out to the entire IORA and the BIMSTEC and various other forums. Even to ASEAN, there have been a hackathon not on underwater, but there have been hackathons for the ASEAN countries also. Ministry of Education has an innovation cell, and they have done hackathons at that level. So we just want to use that framework to propagate UDA. We are in talk with various agencies, and we are hoping that we'll be able to do that. So that is one framework. The second is, Now, if you have to make a policy change, you have to get the entire policy making mechanism to know what is UDA, and we have to reach out. So now we are embarking on a twofold thing. One is we are making initially 10 different e-learning modules to cover, because if you say UDA, there is communities, coastal communities and riverine communities, there is fisheries and the entire fishing ministry itself, fisheries ministry itself. Then there is strategic security is one aspect. Then there is sustainable blue economy is one aspect. So we've identified 10 different such stakeholders, and we are working on e-learning modules for that. And once we have done the initial first level, then we'll go into the details of it. So that it becomes a thing, and it will be hosted on the IGOT platform of the Capacity Building Commission. The second is they are also supporting us to do workshops with the stakeholders. So 10 has been approved now, but it will basically go on in a more aggressive manner. We are also in April, we are likely to host the Honorable Minister, who's Minister PMO. He is also Minister for Ministry of Earth Sciences and Ministry of Science and Technology. So Ministry of Science and Technology, already DST has multiple funding opportunities, and we just need to align itself, and all the secretaries of these ministries will be attending that. It will be a one-day workshop that we are doing in Delhi in April. So that is one aspect to sensitize the whole ecosystem, and I think Defense Secretary will also be there for that, and to make sure that we are able to heard by the right people. And this series of things. We also made a detailed report on which we were tasked by the Niti Aayog, because Niti Aayog is a think tank for the Government of India. So Niti Aayog commissioned a report. They asked us to make a report on what should be the whole of nation capacity and capability plan to take UDA forward. So in that, see, there are instruments called the Inter-University Center. Under the University Grants Commission, there are 8 IUCs that are available. 4 are in education itself. Your NAC and all these things are also one of the IUCs. And there are 4 physical IUCs that have been set up. One is on material sciences, one is in nuclear sciences, one is in Ahmedabad, one is in Delhi. One is in Indore and one is in Delhi. Now recently IUC has been set up. So the third one is in Pune itself, in Pune University, on astronomy and astrophysics. And the fourth one is on yogic sciences, which have been recently set up in Bangalore. I did have an interaction with the chairman of the Parliamentary Committee on Education, and he even tweeted this, that I had a discussion with Arnab on setting up a IUC on underwater. But while I was doing this Niti Aayog report, I realized that the whole uniqueness of the different stakeholders that we are talking about, whether it is traditional knowledge, whether it is coastal community, whether it is coastal governance, whether it is strategic security or sustainable blue economy, if we put everything together, it will lose the uniqueness, or even inland water transport. It will lose the uniqueness of everything, and we may not achieve what we want. So in that report, I said there has to be a diversity versus consolidation debate. And let the policymaker be aware of what it is, and they're trying to. So that is an ongoing discussion. I hope soon there will be some decision on that. And that report is now being circulated to various ministries. It has gone to MOD also. It has gone to MOES also, and we are awaiting the response. We reached out to the MEA to have a series of workshops like this for IORA countries. The Indo-Pacific division of the MEA has processed this. They took comments from MOD and MOES, and both of them have, MOD said that we must be invited as observers. We obviously want them to, but that was the only comment they came, and they said, please go ahead. MEA cannot take on anything without the line ministries on board. And MOES, in a one line, said that this is of importance and we should go ahead with that. So now we are working out. There are 23 IORA countries. Out of that, 18 are ITEC countries. ITEC are the countries which are supported under the ITEC program. ITEC is technology and economics. Government of India funds participants from these nations to come and attend workshops. So that process is on, and hopefully May or June we may have that as well. So we'll get a reach to these countries, and we will be able to, the way you all have come, we want to reach out to the larger international or the regional community. And at some point, we also want to look at certain policy making in the region. One case which is already on is the underwater noise factor. So already we have a project from the International Maritime Organization on managing the shipping noise itself. But I'm reaching out to the government to say that instead of just following what IMO is saying, under the Sagar vision, let us take it up in a little bigger scale and cover various other aspects, because small island is a very big issue. I was in Sri Lanka and I realized I had meetings with everybody, even the naval top leadership of the Navy. The former CDS from Sri Lanka has come on our platform. He is even, if you go to our UDA Digest platform, he's written an article for us. So they are quite keen to get support from us on that. We have an MOU with Pathfinder. Based on their invitation, I was there. But what I could sense is that there is a lot we can contribute to them. And it gives me a confidence. Even like in India, you can see that there are gaps which we can definitely fill up. So many of these countries, we can do a lot to make sure that they can build their capacity. And we are very clear that we are not going to touch their data. We are not going to touch any of their strategic security, we are not going to share or not going to touch their static security data also, any classified data. Even if by mistake something happens from there, and we should not be even blamed for it. So we are going to work on a very, very clear model where their classified data remains with them. We are very clear as MRC and NDT that we are not going to touch your classified data at all. We'll build a mechanism where the data remains with you. We will help you run our algorithms, use your data through our platform, but we will not try to even take access to the data. And this is very reassuring for many countries, because there is an Indian Ocean Commission, which is led by the French. India is an observer. Now we have reluctantly got into it as an observer. And we are driving Indian Ocean Rim Association. Both are for the same region, but we don't talk to each other. IOC has set up a complete thing in Mauritius. I met the IOC Secretary General, and he said that French have given us some machines, they don't work. And we have no bandwidth to make them work. Can you do something about it? I said, we can do, but now I'm an Indian, working in India. Although I'm a private agency, legally I don't need permission, but it may not be correct for me to do that. So I discussed with MEA and they said, you better stay away. I said, okay. But largely what I'm trying to say is that is huge requirement for capacity and capability building in the region. And why I'm saying this to the young people is that this is an opportunity for all of you to be part of this journey and take advantage of this journey. The whole global community is, I was in Europe in December, I went to UNESCO, I went to EU, DG Mayor, Director General Maritime Affairs. I went and saw various ocean innovation hubs in Europe. And everywhere I could see that there is a huge opportunity for us to contribute. Europeans are very good at heavy engineering, something which requires a lot of investment. They're very good at it. But what they lack is the human resource. And I think we have in abundance. We just need to be a little more focused and acquire the right kind of skills. So we see that as an opportunity to make a difference and contribute. So largely speaking, definitely there is seriousness in the country, but a bit of direction is required, which at least I'm happy that government is very open to discussion. I mean, if you look at our first workshop, we had Secretary of Capacity Building Commission who came and spent 2 days with us. We had a lot of senior people coming down to Pune to discuss. They are keen to take things forward. And we are happy that there is a huge difference in the way they are approaching things. A lot of our cases are now getting, Ministry of Earth Sciences has signed an MOU with us. We are very excited to contribute to the larger deep ocean mission and capacity building for the deep ocean mission. In fact, I had an opportunity to interact with the Secretary General of the International Seabed Authority also. And they are also facing this challenge that many countries, now see, it has to be so many countries which have to come be part of this whole International Seabed Authority's initiative of deep sea mining. But even policymakers do not understand the challenges that exist. So they are also in talks with us to build capacity on that front. So we are working with 3 UN agencies. UNESCO has asked us to set up a center of excellence to support Africa and South Asia. Again, in Africa also, if you look at many countries, there are even landlocked countries which have got huge freshwater bodies. And there's a lot that they need to do. Now, even talking about with the increasing maritime activity, underwater search and recovery. I'm using the word recovery in a very, very focused thing because rescue is only 48 hours, right? There won't be any survivor beyond that. But if we have to take the maritime activity seriously, any accident has to first analyze. Whether it's an aircraft going down or a surface platform going on or even an AUV getting lost at sea. I mean, now with so many activities, so many AUVs will be deployed, right? We have to recover and do a postmortem to understand what went wrong. We can't just forget about it. But if you look at the AN-32 that went down in 2016 and various other accidents, we could not even recover it. Now, it's very basic. If right now, if we are sitting here and somebody tells us that there is an aircraft which has ditched at so-and-so place, what is your course of action from now? You have to mobilize assets. Do you know what assets to mobilize? Depending on what is the depth, depending on what is the condition there, whether it is a surface craft or a subsurface craft to be deployed with what kind of payload it has to be deployed, there has to be some SOPs, right? Now, from the time that we have got the report that at so-and-so coordinates aircraft has ditched or whatever accident has happened, is that asset going to wait or target going to wait for us? And the mobilization will take at least 3 to 4 days. Right? Everybody is with me on that? What has happened to the target in that 3 days? Where do we start the search and what kind of search will we initiate? What assets will be mobilized? Don't you think these are important questions to answer? Do we, I mean, that is the tactical part. From a strategic part, do we have those resources? Do we have those assets? Now, to say what we have to do, we need some data. Is that data available? If I say I want X data, will the organization that is supposed to give you that data will respond? It has to be a seamless thing, no? You press of a button, that data should be available to you. So there are certain policy interventions that are required. What kind of MOUs or what kind of, because it has to be a absolute automatic reaction to what is required. And moment you take your cursor, if I have the position in this place, moment I take the cursor, there should be a drop-down menu to say, if there is a search required here, this is the asset that you need to deploy. Are you with me? Is it difficult to do? In today's world, that is possible. And once you say that assets are required, is it available with you? Is it available with your partner organization? Or do you need to find a partner? Is it available in the country or is it available outside? Don't you think somebody has to really understand that and put it into an SOP? Even for the data, what drift, what are the currents, what are the local conditions at that point? Incois has all the data. But do we have an MOU with them on this? Is there a mechanism that seamlessly that data will come to you? Or do you have a setup which will receive the data and start processing it? So there is a lot of, there is an issue of policy intervention. Policy intervention also includes SOPs, best practices. You can't tell the duty officer at MOC to just start reacting, no? He has to have an SOP. He has to have best practices, because everything can't be as per SOP, but what is it? Does he have the kind of training that is required? What kind of technology intervention is required? What kind of computational framework that is required? What kind of data inputs that will be required, and is it that mechanism, is it there? And how will that get transmitted to the operational team which has to be mobilized? Are they standby, or is there a mechanism to put them in standby in some way? Is it available within the organization, or does it need support from the partner organizations? So there's a lot of work to be done there. Even in terms of your underwater pollution monitoring, do we have the complete wherewithal to monitor the status? Do we have sensors? I mean, anything underwater requires to see, to understand, and to share. Do we have the sensor or the platform which can be, it can be even some buoys which can be thrown and you can get the data. I mean, moment there is an oil spill case, if you have those sensors and the buoys ready, an aircraft can go and drop them. The way we drop sonobuoys, it's possible to go and drop them and collect the data, and it can be made available. What are the short-term and long-term impact can be assessed? Oil spill is not the only problem. There are many other problems which need to be taken into account. So are we prepared for all of it? So there is a lot one can do and one can build on. And right from policy interventions to technology, even, I mean, like you heard, this is part of MSP also. You heard Sanskar yesterday. The legal framework is also important, no? Have you thought through, and do you have the permissions from all the authorities with whom, I mean, Ministry of Environment also has to be involved in this. Are the certain acts of parliament aligned to this requirement or not? That has to be analyzed. And many times, some of the acts are in conflict with each other, and it can get sorted out. But somebody has to take it up and discuss it at the top level. Then at the local level, what are the local agencies you will involve? And do you have the mandate to involve them? They have to be also looked at. And then issue of SOP and all that has to be looked at. So, and then capacity building, your own internal capacity building. Is it part of the regular training programs that you run? People have to be aware, otherwise it will come like a shock. People will be completely unprepared for it. So that is a larger spectrum of things that we need to do, to look at. Any questions?
Sir, during the course of your presentation, you mentioned that not only for various other countries in IOR, that in case if you have to indulge with those countries and, without, because what happens is any data underwater becomes a, people are speculative about sharing that particular information. So if you do set up a model, if you give it to them and at the same time to give them the assurance that this will be totally classified, I mean, how do you intend going ahead with this?
No, see, if we have to work with another country, there are two things. One is if it's a government driven, then MEA has to be involved. Then it has to be part of the track 1 and track 2 or track 2.5. Some people say there is nothing called track 2.5 or 3, but people have their own definition. For the youngsters, track 1 is absolutely government to government interactions. Track 1.5 is, along with the government officials, some non-government people, like say a person like me, or if it is related to my subject, I can accompany them and be part of that meeting. So it is called 1.5. Or track 2 can be that government says MRC, go and talk and come out with a whatever thing. Or it could be a group of individuals can go, that is also 2.5 or something like that. Or sometimes you don't want officially to own up and you can send some people to discuss, and if something positive emerges, then the government takes ownership and do things. But the other part is MRC as an individual, private agency, can also go and do certain things. We can provide consultancy to countries where they are completely assured that MRC is a private entity and they will not be. See, the problem with MDA has been that it is outright security driven thing. And that's why, when you drive, I mean, Ambassador Mudgal was here when Sagar Vision was declared in Mauritius. He advised the government to keep it more focused on blue economy rather than completely strategic security. See, smaller countries will always be worried about being completely taken over by a bigger power. Like, I don't know if I've told you, I think I've not discussed with you. Last Quad Summit in Tokyo, they declared two major things. One is data sharing for larger public good. And the second is Indo-Pacific Economic Forum. Now, many of us have written, even I've written, if you go through. What is data sharing for public good in the entire Indo-Pacific region? It's a very big statement to make, we'll share data. क्या आपके pocket में data है, आप दे दोगे किसी को? Where is the mechanism for data sharing? The mechanism is there are 8 data centers, including our IMEC. There is one in Solomon Island driven by Australia and all that. There are 8 data centers. You can go through my paper. All of them are military driven. Do these data centers understand what is public good? When we say public good, we are talking about supporting the communities. Do these centers understand what is public good? The second is, are they open to sharing data? And when I'm saying open to sharing data, you have to have a calibrated approach. What is shareable and what is not? You have to have an SOP. Do we have that? I mean, in my time in the Navy, every piece of data was top secret. Yes? Any organization, I was in underwater ranges, any data in underwater ranges is top secret. then where is the question of data sharing? But according to me, every piece of data cannot be top secret. So have we made a mechanism where we can distinguish or calibrate what is top secret, what is classified, what is unclassified? Then only you can say this much can be shared. Otherwise, this is just a lofty announcement at the summit level. It's funny. If you read some of the articles I've quoted also, if you read, the analysts have really made fun of. It's very irresponsible when global leaders come together and make such announcements, which is not doable. Quad, US, Japan, Australia, India. So many of these summit level declarations are said to be high level parties because nothing comes out of it. It makes no sense. I mean, that's why other countries in the region have no faith in the leadership. Because it doesn't match up with the reality down below, right? And the other aspect of it is, who's going to provide the data? Hawkeye 360 is a US company which has collected a lot of satellite data. It is a business opportunity for a US firm. It's not I'm saying, it's available in literature. So you are actually using global forums to market your own companies. Is it acceptable to a smaller country? It's not. So are they going to accept your leadership? I mean, it's like you are making a not-for-profit entity and saying, well, you'll back channel commercial activity through that. So all this has been discussed. Hawkeye 360 is going to be, because they have invested big time. They want return on investment, so this is a route. So those are the issues we need to really be aware of, to make sure that we really understand what is being said and what is being done in the garb of global leadership. And that's why the US hegemon is now declining, and people know what is the capability that is available today to support such announcements. Okay, so we have our MRC Research Fellows presentation now. We have Romit, who will be talking about sediment classification, and followed by Catherine. So Romit, over to you.
Yeah. So good afternoon, everyone. I'm Romit Kaware, a research fellow at MRC and pursuing my undergraduate in civil engineering from IIT Delhi. So today I'll present about the sediment classification, its application, and some of the policy interventions in the tropical waters. So our discussion will be about some sediment classification, some introductory part about it, then the three major areas of interest we will talk about, and then we will see what are why the policy interventions are needed in the tropical waters. Can we formulate a policy? Policy formulation can be done, and then some concluding remarks. So one of the first question that comes to our mind is, why should we study the seabed? So the complex nature of the seabed is due to the various processes that had occurred in millions of years. Due to this, various recreational, economic, military, and oceanic applications need the qualities of the sediment or the seabed. And then for locating the various marine environment and the operation of the various structures, say drilling rigs or oil rigs are there, many support structures, they require the geotechnical applications of the sediments. The density or the moisture content, the shape, size, structure are also needed in order to have proper construction of these offshore structures. The seabed structure is also vital for planning the submarine routes, as well as different marine environments are also characterized by the sediment type that is present at that particular location. Hence, it influences what are the various abiotic and the biotic components in the marine ecosystem. So, like we have been like studying the like seabed and conducting research activities for like many decades now. So conventionally, if we have to conduct some test and all, the detection site is located and then physical samples are being extracted, and then many tests are conducted based on what is the application, what are the needs and all. But again, these tests are conducted by having some we have corers and grabbers are there. So there is a vibro core sampler or box sampler is there. So all these samplers are there which may physically extract the samples and all. But again, these are limited in scale, time consuming, and as well as maybe expensive as well. So like more recently, there has been remote sensing based acoustics classification system. So they use the various sonars and all, and has a lot broad coverage as well as is like cost effective as well. So these are the new modern day techniques that have evolved. Now apart from all these technologies, we also need to identify what are the corresponding stakeholders, have proper consultations with them in order to have a holistic development without any delays and all. And in order to do this, we also need to understand what are the various policies that are there in place when we consider the global, regional or the national scale, and to understand what are the policy gaps that are there when we come to the Indian Ocean region. So like with the development of the various technologies and all, a lot of interest have been developed in the many applications of the seabed. So we see that the exploration and extraction of the various minerals or other resources require offshore construction, support structures and all, and these are all like supported by the foundation. So these foundations are like how can we design them, the strength of the foundation, or are determined by the sediment bearing pressure. So it is significant in the design and detailing part of how the site would be selected, what kind of structure process needs to be involved for like constructing the particular structure and all. The other one is like there is a lot of marine resources when we consider the living resources. So they are exploited with the benthic boundary there in the lowest part of the ecosystem in the particular water body. So their management also becomes crucial as we need to establish what is the particular, we need to identify what is the health status and all, monitor and maintain our biodiversity and all. Another part is that a lot of trash deposits, say marine litter, is been like floating around our oceans. Like a lot of pieces are there, and they may cause a lot of problems to the marine ecosystem as well. Hence, we need to identify them and then choose parts of like recovery needs to be done. Then a lot of communication between the islands and the mainland is done through underwater cable, underwater transmission. They may be of commercial use or maybe of military use as well. So planning these cable routes also is another interesting like application. Then with the improve like technology is evolving day by day, and with like a lot of stress on existing resources, there has been new mineral oil gas resource explorations in the untapped regions of the Indian Ocean region as well. So all these are the various interests that are there in the seabed. We will talk about three of them. The first one being the sediment bearing pressure. So the sediment bearing pressure is the sediment bearing pressure is basically the pressure that can be exerted on the sediment which is in contact with the seabed which is in contact with the seabed. Now the pressure that can be exerted or can be like taken by the sediment depend on the characteristics of the sediment, say the moisture content, density, the roughness and the texture of this sediment as well. Thus these sediment bearing pressure is necessary in order to have a good engineering and geotechnical investigations about the various foundation design, retaining wall or the seismic soil stabilization as well. It is necessary to like have these sediment bearing pressure analysis in mind in order to have a safe and secure structure which will not collapse or fail under excessive settlement. Thus the structure may be of like strategic importance or economic importance as well. So example, if the army wants to deploy some amphibious vehicles or say tanks in a in a subtop in a like shallow water region, so they may require what is the sediment bearing capacity of that particular region, or else the assets which they are going to deploy, they may sink. So this kind of studies have extensive military applications as well. So when considering how can we calculate the sediment bearing pressure conventionally, what happens is we have a detection site, ships वगैरह are sent, and then they physically extract those samples, and then based on what are the parameters that are needed for the calculation, extensive laboratory tests are performed. So there have so many tests may be performed, triaxial tests may be performed on them to determine what is the strength of the sample, or to characterize what is the texture, and classify it on based on the grain size and all. But again, as I mentioned, these are time consuming and do not have a lot of coverage as well. So that's why these acoustic systems which deploy the use of the various side scan sonars, multi-beam echo sounder, or the sub-bottom profilers, they can be used because again they have broad applicability as well. So like this in the image you can see, these can be mounted on AUVs, submarines, on or ships, depending on the specific needs and the resources that are available. Again, this image shows how like these acoustic systems, they're complemented by having some mathematical models or some data analysis models as well. So this is one of the model, how the input data is taken, then what are the various processes through which it can go in order to have different parameters to be determined. Correction factors as well can be determined. And this is a conventional borehole data of the geotechnical investigation of the soil to classify what type of soil it is, at what particular depth, or what is the soil type, what is its classification, then what are the various sediment grain size classification is present. So this is one of the conventional way that it can be done. So coming to the policy part, what are the various policies that govern the construction in the mostly in the exclusive economic zone region of the of a particular coastal state? So for this, the United Nations Convention on the Laws of Seas, their UN clause, it has various guidelines for like managing the oceans, including the EEZ, the seabed, subsoil, and the water column as well. The International Seabed Authority is there, which has mandate to regulate activities in the international seabed as well. In the construction part, it has various regulations and like activities for the exploration and exploitation of the particular international seabed, and then how can the environmental impact assessment be carried out, what are the various monitoring and reporting guidelines, safety standards for the various operations, these are all mentioned. Apart from this, the convention also has the various articles. So article 56 has provided the coastal state with the various jurisdiction in regards to the construction or the establishment of the artificial island, offshore construction installations and structures. Article 60 has also some relevant provisions regarding the same. Coming to India, there is the Territorial Waters Continental Shelf and Exclusive Economic Zones Act, which has the legal framework for managing and regulating India's maritime like zones, which includes construction in the EEZ as well. There is the Coastal Regulation Zone, which has like the under the Environmental Protection Act has various guidelines for coastal zone, and for construction activities in the EEZ, what are the various requirements for obtaining environmental clearances and all. Then there's the EIA notification, which involves that any construction activity which may cause a significant environmental impact should have an EIA done before it should be like approved. Then there is again the National Green Tribunal dealing in cases of environmental law disputes as well. So there are a lot of policies internationally as well in the national level as well. So coming to our next area of interest, that is the benthic ecosystem assessment. So benthic ecosystem is the ecological niche lying in the lowest region of the water body and is in contact with the substrate or the bottom. They are necessary because they not only help in the nutrient cycling and energy transfer, but they also help in identifying and monitoring the health of the ecosystem that is present. We need to monitor these benthic ecosystems in order to like firstly see the natural variability of these particular benthic ecosystem, then to see what are their variation with respect to many other natural factors, say ocean warming is there, and then in order to have a time series or a future predictability on how the various risks associated with the current scenarios would affect these benthic ecosystems, or we can say these ecological assets. So that's why these monitoring systems are required. So again, when we come to the technology part, how can we identify these benthic ecosystems? So the traditional methods involve having biological samples there. There would be sediment grab samples or dredges would be there, or there would be rapid visual assessments of the particular parameter by diving surveys as well. Now with again use of technology, with the development of technology, there are these acoustic sensors, which use again we can use the side scan sonars and all. These can be mounted on the AUVs or the remotely operated vehicles as well, so that they can be pre-programmed in order to investigate some isolated areas. And then there are various benthic indicators as well, so depending on what region you want to identify, what type of species you want to identify, different types of indicators are developed to determine the health of the particular benthic ecosystem. So there are like most of them are in the Mediterranean region as well. Then with the like large scale there is a need for a large scale spatial data on these benthic species as well. So various computational simulation and modeling techniques have also been developed. One of them is the distribution modeling techniques that has been developed, which lead to a full scale prediction of the spatial benthic ecosystems as well. So basically all these technologies are all these technologies, and they all depend on what are the various users need, what or input parameters are needed. So we need to understand the more larger source path receiver model. So basically what are the various input parameters you need, what are the parameters you need to study, how are you able to collect the data, source the various data, then through which path you want to analyze these the data that is there, and then depending on the receiver, how you want to visualize it, how you want to show it to the receiver. So there are three aspects in this: the 2C, to understand, and the 2 share aspect. So in the 2C aspect, we would like to see what kind of sensor needs to be used, what hardware needs to be sourced, what are the various techniques. Do we need to go to acoustic path or through optical technique way, how we need to be deployed those sensors, either they need to towed by submarines, ROVs, or be mounted on ships, be towed, how we need to what vehicles need to be deployed, and what is the specifications of these sensors, because like depending on the acoustic sensors, depending on the frequency, different so the range of the depth through up to which we can determine or classify these sediments, they also vary. So what are the specific specifications of the sensors used? Now once we have the data and we have collected it, the next part is how can we interpret the data based on what the parameters are needed. So there may be a lot of data pre-processing, post-processing, a lot of data analytics which involve the use of machine learning or artificial intelligence, like some use unsupervised learning, supervised learning, some mathematical models like in the sediment classification there is a Bayes-Stall model, it can be used. So what kind of, do you need a Fourier transform series and all? So depending on the specific needs, how these data processing techniques needs to be used, needs to be like analyzed, and then according to what type of user is there, what is their need, we need to show them differently what type of data. Like yesterday Arnab sir told, if a policy maker is there, the policy maker would require to have some data of some decades or maybe 100 years. So how on what time scales we are trying to represent to data. Some user may require the data on a we need to develop some web-based graphical user interface, or some would require a mobile application for the data to be presented, or for some application maybe on the hardware itself the data needs to be presented. Again, how can we show the data through maps, tabular through tables and all? Again, in this the marine special planning would come to a rescue. So basically then what kind of application it is? So again, the Navy would have some different specifications of data than a researcher, and some may require a real-time data feed. So how can we share this data? So all these aspects are different research topics at all. So depending on what type, what is the or main focus of this research, different research techniques can be used. Different. So yeah, that's the main thing we need to consider. And then this is the the distribution modeling method, the computational simulation, how it basically shows how the concept may be done, how various input data can be carried, then how the model parameters can be thought of, what are the various model parameters, and then once we have some predictions, how can we use them to monitor them. We could predict some future scenarios as well. How can marine spatial planning be used in it? And also again, a lot of planning and policy formulation would also go into it. Now the image on the left, this is an reconstruction of a particular coastal landscape from an UAV survey, while on the right you can see the digital elevation models of a particular location. Through bathymetric surveys they have been able to reconstruct the topographic scale as well. So again, these techniques would help us in order to map our seabed in extremely new ways. Now uh, coming to the policy part. So like most of the international community has been there to have various policies in areas which are beyond the national jurisdiction as well. So internationally we have the International Union for Conservation of Nature. It has the ocean governance, which has various processes and agreements in place for the protecting areas which are beyond the national jurisdiction as well. The Convention on the Laws of Seas, it has dedicated part 12 for providing legal protection on the marine environment as well. There is the Article 207, which has duties of states towards the rejuvenation and the preservation of these marine ecosystem. The Article 208 talks about the various seabed activities and how the human activities would lead to the various survival of the benthic communities as well. Coming to the India, we have the Article 48A and the Clause G of the Article 51A, which mandates the state to protect the forest and wildlife of the country, which includes the marine ecosystem as well. The Environment Protection Act is there, which there's the Water Act, which banned industry from trying to pollute the environment and the marine ecosystem as well. In the US, the Environment Protection Agency also has various guidelines in order to how can we monitor, assess, conduct surveys of these benthic ecosystems. In the EU, the Marine Strategic Framework Directive, it directs the EU member states to assess and monitor their marine environment to achieve a good environmental status, its biodiversity, and its seafloor integrity as well. So again, nationally, regionally, globally, a lot of these regional agreements are in place. Now, we also look into a case study in order to look why such policy formulations would pose some kind of complexity as well. So there was a case study in which they basically wanted to know the ecological status of 700 sites in the Mediterranean region. So as very little quantitative data or research data is there, which they needed to have a comprehensive study which would represent the actual health of the marine ecosystem in the Mediterranean region. So again, what the researchers tried is that they took 4 major habitats, and then as I mentioned, there are various benthic indicators. So depending on what type of region they wanted and what type of species they wanted to assess, they used this indexes like the rapid easy index or the Carlet index, and they also calculated the ecological quality ratio. So basically the ratio of the indices at the specific site and to the indices at the reference site. This study, however, highlighted that there are differences in this habitat classification system, monitoring methods, and the threshold methods that are there between the various nations. This hindered the actual representation of how the ecosystem is getting degraded. Also, there are a lot of indicators that are being used which are making the comparisons difficult, thus impairing how to have a reliable and an extensive picture of the health of this particular benthic ecosystem. Thus, according to them, there was an urgent need to achieve a consensus on which type of data needs to be collected, what indicators need to be used, how can we classify them based on the marine ecosystem health, because the current policies are too fragmented based on the various decision makers, the nations, the researchers, the policy makers, and the practitioners as well. So again, a lot of agreements or a lot of indicators in place lead to more complexity. Now, coming to our next application, that is the abiotic element detection. Now, it is one of the most crucial parts which involves identifying and locating objects which are not part of the natural seabed environment, which may include lost or discarded items or wreckage from ships as well. Plastics, which also considered a major part of marine litter, are just lying across our oceans and all. So this forms a major part of this abiotic elements. Another one are the polymetallic nodules. So there are manganese, cobalt, or copper, which are present in good quantities in the Indian region as well, in potato-sized nodules, which are called as the polymetallic nodules. So these are also of various commercial viability as well. For some facts, India was the first country to receive the status of pioneer investor in the 1987, and was allotted an exclusive area in the central Indian Ocean for this polymetallic nodule utilization. In fact, India is in the top 8 countries which is implementing a long-term contract for this exploration of these polymetallic nodules. So again, you can use these new modern machine learning algorithms as well. So you have some diving surveys and also, and then you can integrate these machine learning algorithms to have real-time classification of what kind of object it is, whether it is a say sea urchin and all, and then or a plastic object and all, or a rock. So depending on what kind of object it is, we can classify these abiotic systems as well. So again, this shows a conceptual model of how the marine litter can be, how can we understand the problems of the marine litter, how can we map them, we have some modeling techniques, how can the various stakeholders be brought in, how can the legislation involve in managing these marine litter, and then how can we recycle them, reduce them. So basically all of them are involved in a particular strategic planning. So again, coming to the capability part. So again, if we need to conventionally see what kind of litter is there, we would have some grab samplers in the particular detection place. We have these crawler systems. So these have some, excuse me, these are some crawlers which would be there. There are pumps, vacuums which would then take in those systems, recover these some of these samples in order to have extensive laboratory testing and all. Again, there would be diving surveys in order to visually inspect if some of these techniques may not be able to effectively classify. Now with the rise of these acoustic systems, we can use sonar, or some of these foreign objects would also have magnetic properties which could be taken up by the magnetometer. So we could have magnetic surveying as well. Again, we could have videographic surveys, optical imaging, or with the growing technologies, the use of machine learning, we could have some. So some researchers tried to integrate the machine learning algorithms, like you only look one model was there. Some use the regional proposal network RPN, while some use the faster RCNN networks in order to integrate them with the video surveys that were conducted in order to have a proper classification system in place. So these could be again, these videographic surveys would again be conducted by placing them over AUVs or ROVs. They could be like pre-programmed or again autonomous. So yeah, with growing technologies, we could have proper like location and identification on what kind of marine litter is there, and then proper recovery methods could be developed. Coming to the policy part, so according to the convention of the United Nations Convention on the Laws of Seas, so it has various laws for the seabed and ocean floor, and how can we use its resources, and then these resources are common resource for the humankind, so they must be effectively used, and not a lot of pollution be caused. Then there is the International Convention on the Prevention of Marine Pollution from Ships, or the MARPOL, which is developed by the International Maritime Organization. Coming to the EU, there was the Barcelona Convention in 1976, which aimed to protect the Mediterranean Sea against pollution and preventing and eliminating pollution by dumping from ships and aircraft or by incineration at sea. In India, the Ministry of the Earth Sciences, along with the National Center for the coastal research of this temporal and spatial distribution of marine litter along the Indian coast and the neighboring seas as well. The Ministry of Environment has the plastic waste management rules, under which like they had prohibited the manufacture or stocking, import or distribution of plastics that are less than 50 microns thick, in order to prevent this marine litter going into the Indian Ocean region as well, which may cause harm to the marine ecosystem as well. So, having seen that a lot of these policies are there in place, say nationally or regionally or internationally, so we need to know why do we really have some policy frameworks in the Indian Ocean region. So we may first look at some facts of the Indian Ocean region. So the Indian Ocean region is one of the busiest tanker route in the world, carrying around 500 million metric tons of oil. Now, most of this oil may get seeped into the or may get there may be some oil slips which may cause a lot of damage to the coastal environment and the mangrove forest along with the coral reefs as well. And then again, the Indian Ocean region is abundant in the manganese nodules as well. There is a high concentration of the politically unstable, governance deficit, and the conflict blown nationalities as well. So there is Indian Ocean region is an very interesting and unique place because it is of commercial and military application of the coastal states as well as every other major power of the world as well. So again, there has been a lot of when considering the various international conventions that are in place, a lot of problems have also been come up. So like there many observers have noted that there are a lot of reception facilities in terms of their high usage costs are there, and so many of the shipping companies tend to they just ignore the Marpol convention, and then they and then dump their litter overboard. Many of them, the Indian Ocean region countries also have less agreements in place when we compare them to the European counterparts, or we say the United States as well. Many of these countries though have their respective laws and regulations, but again their governance deficit and are largely ineffective to in mitigating the illegal, underreported and the unregulated fishing as well. We also need to consider the Indian Ocean region countries have some of the most polluted rivers as well. So a lot of these rivers may dump their marine litter into the Indian Ocean region only. Again, many countries lack the proper standards, guidelines, and enforcement mechanisms owing to the limited scientific data as well. Again, there is not a single organization that would encompass all the Indian Ocean region countries. So there is the Indian Ocean Rim Association, but again it would think of its focus would be on the trade and not a lot of on the social, political or the socio economical issues as well. So regionally there have been a lot of problems regarding the international conventions that are in place. Now coming to the Indian part, there was an issue, said the Dharma port construction was there in Bhadrak, Odisha. So it also gained a lot of reasonable attention because it was close to the vulnerable olive ridley turtle nesting place as well. So it also drew a lot of attention. Were there proper environmental consultations in place? Again, since there are a lot of laws in the state on the state and the national level, there might be some kind of mismatch and a lot of complexity occurs. So there was a ship which had some toxic substances which was due to under the Indian coast. So the Gujarat Maritime Board and the Indian Customs they let it through pass, but the Ministry of Shipping and the Ministry of Environment sought further details. So there is a complexity and there is a mismatch of information as well. Again, there is a lack of capacity, skills, and access to cost-effective technologies that make it difficult to like overcome barriers of sustainable management of the aquatic resources as well. Uh, Again, the region is concentrated with a lot of governance deficit. There are a lot of political conflicts as well. So there is a lack of regional trust between including the various countries as well. So we have seen that the ever-growing tensions are there in the our maritime neighbor only. So in the South China Sea, there is a rise of dominance over the particular Indian Ocean region as well. Thus, it is high time that particular frameworks are to be worked on for national interests. Uh, Again, whilst a lot of excessive delays are also led through some projects maybe of economic and strategic importance as well. So we saw the Mumbai Worli, there was a Worli sailing which saw excessive cost overruns, a delay in 5 years as well. Now, in accordance with the government of India's new vision by 2030, it highlights blue economy as one of the 10 core dimensions of growth. And so there is a need of a coherent policy which has different sectors which improve the lives of these coastal communities, accelerate development and their employment as well. Thus, India must recognize its position at an economic and strategic access and then strive for an efficient and sustainable utilization of these already scarce and untapped ocean resources in order to have these ocean related opportunities, capabilities, and then safeguarding the environment in regards of the UN sustainable development goals as well. Again, you can see this picture shows that when we come to the Indian Ocean region, it lacks in a lot of environmental baseline and the deep sea mining scientific gaps. So if anyone wants to have a proper study or research or formulate policies as well, the data is limited. Not a lot of data is available in the public domain. So there is a pressing need to have a like a formulation of the policy coming to the sediment classification framework. Now this could be worked upon utilizing the current floor which is given by the national framework for sediment management or the UDA framework, and then some extensions can be done upon which would include the blue economic policies as well, because the like as the G20 presidency is with India, one of its pillars is the blue economy, which is a more coherent issue coming to the global south as compared to the global north. The security and growth for all in the region, that is the Sagar initiative or the BIMSTEC, they are largely contributing for this advanced ocean cooperation and blue economic activities in the region. The blue economic policy also proposes to regulate various activities under the sustainable development goals and then bring in the private players as well, which could have a lot of investments and partnerships in the Indian Ocean region. The maritime sector is also going through an Industry 4.0 revolution. So a lot of new technologies like advanced robotics, these sophisticated sensors are there, Internet of Things, machine learning, cloud computing. So all these are also required in order to have transformed the marine sector and then have a greater growth and development. Now, keeping in view of the various stakeholders that are there needs to be a good consolidation between all those stakeholders. Upskilling of those stakeholders needs to be done with proper value addition as well. Thus, a comprehensive plan would also incorporate the freshwater systems to enhance the maritime security within our borders as well. Science and technology is also one of the key drivers of the safety, security, and the sustainable development of our oceans. Thus, it is important to know what are our what do we do not know about the various undersea ecosystem, how the various interactions are there between the components of the marine ecosystem, and how human interventions are basically causing a variation in this working of the marine ecosystem and the total working of this ecosystem at all. So in conclusion, I would suggest that India should leverage its position in the Indian Ocean region to have a proper policy framework, including the blue economy, the sustainable development goals, ensuring that there is peace, harmony, and security within the mighty Indian Ocean. So, with the comment of the formal UN Secretary General Ban Ki-moon that Earth is our only home, together we must protect and cherish it. I'll end my discussion. So. Thank you.
I hope you can distinguish between the presentation done by Rishika and Romit and also Sanskar, because what Romit is addressing is the sediment at the bottom of the water body. And there are varied dimension, and what is important is that if we now need to look at the smaller players to get into the underwater startups, a lot of data or information is required. The startups will not have the bandwidth or the resources to do some basic study. There is already a GIS policy announced by the government. The blue economy policy is going to be announced very soon. And I think it is very fundamental that some of the basic information must be available for somebody to build on. Otherwise, it becomes a non-starter right at the beginning. So from that perspective, we feel that this kind of work is, so this is just about building the basic framework, but then we need a massive multiplier network of startups who can go and actually region specific, application specific, sector specific mapping and then take it forward. So if there are no questions, chat mein hai kya? Okay, there's a question. Romit, do you want to answer that? There's a question in the chat box.
So yeah, like I believe that as Arnab sir mentioned, a lot of data is there. So like we may have a lot of we can based on the various different applications, different kind of data can be done. So again, sharing of this data, how can we share between the various or various users or various nations? I think cloud computing and all can like really help in how we can share the data between various stakeholders are there or between various nations are there. So yeah, I mean, because again it is not only like because again the Indian Ocean region is a large area, so it's not that only one country can be able to like correct all the data. So it's a like a lot of countries need to come together, and I think in that way, in our, how can we share our data, how can we like have this coherent policies as well. Again, as I mentioned, that in order to have any studies or any policy formulation order, data is required, and the Indian Ocean lacks a lot of scientific gaps at their environmental baselines or other key, as I mentioned, the Mediterranean study. So the Indian Ocean region lacks in this. So I guess yeah, cloud computing could really help in that.
Yeah, I think there are many tools, as you have seen. There are a lot of presentations that you've seen, and so those tools or those computational infrastructure will be extremely critical, and we'll have to have a combination of many such tools. And as somebody had even asked the question about the supercomputing mission versus the quantum computing, and so these are all tools that will be required, and they can all contribute to the larger. So I mean, at the policy level, the government will have to take a call, and it's also when we talk about the digital transformation, there are also concerns of security. So are we really prepared for those kind of, and it's also a political question, because will the nations in the region allow the data to be available on a common platform is also a question that we need to answer. So there has to be a multi-pronged approach. The entire policy structure has to be looked at. The technology intervention has to be looked at, and also, the capacity and capability building has to be looked at very, very differently, both at the national as well as the regional level. I hope I've answered your question. So we will move on to the next. Thank you, Romit. It was a good presentation. We'll move on to the next presentation. Catherine, kindly make your presentation.
Good evening, sir. Good evening, everyone. My name is Catherine, and I'll be presenting today on Indus Basin Water Future. So this is our Indus Basin. we have the major tributaries Kabul in Afghanistan, and then Jhelum, Chenab, Ravi, Byas, Satluj flowing through India into Pakistan. The riparian countries for the Indus Basin include the majority is in Pakistan, 47%, India 39%, China 8%, and Afghanistan 6%. But China holds a very important position because it is the upper riparian to majority of the rivers. And then in India, we have Jammu and Kashmir, where the Indus Basin contributes the most. The whole of the Jammu and Kashmir is actually encompassed by the Indus Basin. And then we have Himachal Pradesh, 16%. And Punjab is heavily dependent on the Indus Basin, the breadbasket of our country. And then Rajasthan, 4.9%. And the Indus Basin is actually home to about 268 million people. In this presentation, I'll actually go through first the historical context of how the Indus Basin governance evolved and how the Indus Water Treaty was signed. And then what is the current scenario of the Indus Basin in terms of its, in terms of our governance and also in terms of the water scenario. And then what are the conflicts around the Indus Water Treaty and the basin, and what is the way ahead? So coming to the historical perspective, there are various events that actually impacted how the Indus Water Treaty was formulated. First of all, India and Pakistan had been newly partitioned, so there was a question of territory and sovereignty. So when the Indus water problem arose, it actually became a very vital turning point for how India and Pakistan define their boundaries. So the land was divided by the Radcliffe Line. So how was the water going to be divided? Because this was something that was actually not in anybody's control. So the basin was transboundary. So how are we going to define the territory, and how both the nations are going to have define their sovereignty? And then second, the riparian positioning. So India is upstream to Pakistan in terms of the Indus Basin position. So India actually claimed the equitable allocation, because India was like, I have majority of the land, I have a considerable amount of the land where the Indus Basin is, Indus waters are flowing. So I need an equitable amount of water. But then the Pakistan was like, I want prior appropriation, I want to apply prior appropriation rules, because most of the irrigation structures that the Britishers had built during the time of the British were in Pakistan. So so Pakistan was like, we already have the water structures, so we need the water, we need more water allocated to us. So that was also one of the major points that was discussed. And then India wanted total sovereignty of the eastern rivers. So the eastern rivers were what feeding Punjab. So, and India was under a lot of stress to feed its population. So from the food security point of view, India actually weighed its pros and cons and decided we need total sovereignty over the eastern rivers. So demanding that, they had to give up something which was the western rivers control. And then Pakistan also wanted independence from the upstream control from India. So the problem actually arose when India actually blocked the water going into Pakistan, because most of the headwork for the irrigation system was in India. After India and Pakistan got divided, the irrigation canal network was in Pakistan and most of the headworks was in India. So India had the control over when the water was flowing into Pakistan. So this created a huge security issue for Pakistan. And then in India, we had a lot of internal conflicts, wherein the farmers in Punjab and Haryana and other places were like demanding the government to actually provide for irrigation system for them, because their fertile land was laying barren. And then in the Punjab borderlands, as I said, there was constant conflict, like the local level conflicts, which were creating a lot of problems. Looking at the whole scenario of how India and Pakistan is juggling with all of this, David Lilienthal visited India. He's an American technocrat and a water manager. So he visited India, wrote a paper in 1951, which actually grabbed the attention of World Bank. So the World Bank started getting interested. World Bank was at that moment a very young institute, about a decade old. So they were concerned about how in the South Asian, the volatility in South Asian countries could impact its lending programs. So it was also concerned about how to solve this particular issue. So they wanted to mediate the whole treaty. And then other Western policymakers were afraid of the Cold War that was about to that might happen if India and Pakistan keep on fighting. And then Pakistan started to give in, because India and the World Bank actually agreed to give a certain amount of money to create a news canal network for themselves through the western rivers, and give up the eastern rivers for India. In this whole discussion, initially when David started negotiating and mediating, there was a lot of focus on the science, to consider the Indus Basin as a whole hydrological unit. But as the negotiations were progressing, the politics took over. So finally, the political goals or agendas or the notions of Nehru and Ayub succeeded, and most of the scientific ideas were left behind. So the treaty is actually a very engineering heavy plus politics heavy document. And Indus Water Treaty is today regarded as a very successful document, because it has managed to overcome a lot of standoffs and wars between India and Pakistan. And at that moment when it was being signed, it was also a historical moment of decolonization, when India and Pakistan accepted the mediation from World Bank, and they weren't told to do so and so. So this was a very important moment of decolonization. So we need to appreciate the historical perspective to appreciate what we have today. And so the treaty provisions actually said that the eastern tributaries of Indus, Satluj, Beas, and Ravi, were for India's exclusive use. So this amounted for 33 million MAF. And the western rivers, the Indus, Chenab, and Jhelum, whose mean annual flow is 80 MAF, were allocated to Pakistan. And in these western rivers, India was allowed to construct hydroelectric power plants of run-of-the-river models only. So as you can see here, the eastern and western rivers are pretty clear. So it was a very, it looks very easy how they did it, but it took about 10 years to actually formulate the Indus Water Treaty. So the Ravi, Beas, and Satluj on the eastern side now is being used by India exclusively, and Indus, Chenab, and Jhelum is used by Pakistan. So what is the current scenario? So this is all the riparian countries of the Indus Basin: China, India, Pakistan, and Afghanistan. So here I have compiled all the data available on the amount of water which is coming from China, which is originating in India, and how much of eastern and western rivers is available in India, and how much is flowing to Pakistan and through the western rivers and eastern rivers, and how much Pakistan is getting from Kabul and other tributaries, and how much is finally going to the sea. So we don't have a consensus, of course, on what is the actual number. So if you can see every box has multiple numbers, because for the same quantity we have different numbers. So there is definitely a gap where we don't have the required data, we don't have an accurate and dependable data. So the point of this particular chart is like, India needs to work on its data collection and real-time monitoring, so that if we don't have the actual data to say how much we have and how much we are leaving. For example, in the eastern rivers, we are supposed to use all of it, but to Pakistan, we are giving actually between 2.4 BCM to 11.1 BCM. So we don't know actually how much is flowing into through the eastern rivers into Pakistan. And recently, there was a lot of political tussle after the terrorist attacks, and then this eastern river water was supposed to be a point of contestation, because are we actually like giving up all the water, or are we using all the water? Is Pakistan just using the water even though the Indus Water Treaty says that it's for us? Is our technology is properly in place to utilize that water? So all of those questions cannot be answered if till we have the necessary data. So and other important thing that is impacting our basin is the climate change. So of course, there's going to be a decline, and the decline is mostly going to be in the snow melt. The flow of, according to the UNDP study, the flow of Indus, which receives 90% of its water from the upper mountain catchments, could decline by 70% by 2080. So are we ready to have a climate-proof future? So similar studies are available, but they don't have enough data, or they aren't region specific, or specific enough to have proper interventions designed for them. Coming to the major issues in the eastern rivers for India. So globally, the climate change is affecting all the major water resources. But in India, if we talk about it, what are the issues that we are facing when we are talking about the eastern rivers? So the eastern river water is, all of them are allocated to Punjab, Haryana, Rajasthan, Jammu and Kashmir, and Delhi. So it's a very, so till Delhi, it's dependent on on the Indus River. And our canal systems are really old, around 200 years old. So they are silting, and there's a lot of water loss. So there's been repairs happening, but then it's not giving the desired result. And then we also have the farmer issue. We are growing paddy and rice heavily, which is like draining the water resources and soil fertility. So how do we add value to the farmers and also increase the farmer income without damaging our natural resources? So the water quality, the groundwater quality, the surface water quality is in a huge mess. The soil quality, because of the heavy use of fertilizers, this might not look like issues which concern the bigger picture, but they are, because the farmers are one of the major stakeholders in the Indus Basin. And then what are we doing to combat the water stress that is happening? So right now we are using the water resources at 186% of its of what it's capable of. So the groundwater and surface water. So how are we going to manage all of that in the eastern region? And the major issues that are in the western rivers, of course, is the first hydropower demand. So we have a lot of capacity to build hydropower plants in the western rivers. But because of Pakistan's continuous interruptions, we haven't been able, the projects have delayed considerably, which has cost a lot of money, which has cost a lot of time. So this is one of the major issues. And then the flood and sediment management of the dams, because Himalaya is a very young mountain. So the sediment issue is particularly very important. And this hasn't been, we haven't been able to take care of that because the treaty kind of specifies certain design restrictions for the dams, wherein we cannot alter the design to incorporate technological advances to manage sediments. So this is one of the major issues that we are facing right now. And then cross-border terrorism, because for Pakistan, Kashmir is the claim it has on Kashmir has intensified because Pakistan's economy is dependent on Indus Basin. Most of it, Pakistan is drained by the Indus Basin. It doesn't have other sources. So Kashmir, where most of the rivers originate, becomes a very important important point where they claim strongly. So terrorism act is an eventuality of what their other policies are. So our relationship with Pakistan actually will actually influence how the Indus Basin is managed and governed. So in the treaty, we have the following mechanism for conflict resolution. So the first is the Permanent Indus Commission, wherein the two Indus commissioners from India and Pakistan, they constitute the Permanent Indus Commission. So if there is any particular problem, any question, so a question is raised with PIC. And if that question is not solved, difference is deemed to have arisen, and a neutral expert is invited to actually decide who is in the right and who is in the wrong. And then if that doesn't solve the issue, we have a court of arbitration, wherein after a dispute is arisen, a court of arbitration is established to resolve the dispute. So given this mechanism, our treaty has survived two major wars between India and Pakistan and has survived a number of military standoffs. So there is something about the treaty which has, in its crux, which has managed to keep peace between India and Pakistan in terms of its water allocation. But has it kept with the changing times? That's the question. So the most recent conflict that India and Pakistan had with respect to the Indus Water Treaty was the Kishan Ganga hydroelectric power plant. So Pakistan's objection was that if KHEP is built, it will reduce the water in the channel that is irrigating thousands of acres on its side, and also impact the other power plant that it has it has planned for itself, Neelam Jhelum project downstream. So as you can see in the diagram, Kishan Ganga is in the top right corner, where there is a tunnel, KHEP tunnel, connecting it to the power plant. So the power plant is actually at the downstream of the Kishan Ganga dam. So the idea here is that Kishan Ganga flowing north on the north side of Jhelum River actually creates a force wherein a natural force which can be utilized for power generation. So this same concept has been used by Pakistan to do the same. So, but who conceived the idea first is the question. So this is where India actually had the upper hand. So India had conceived the idea in 1990s. So when it came to the court of arbitration, India actually had the upper hand, of course. And so what the Indus Water Treaty says is that where a plant is located on a tributary of the Jhelum on which Pakistan has any agricultural use or hydroelectric use, the water released below the plant may be delivered if necessary into another tributary, but only to the extent that the then existing agricultural use or hydroelectric use by Pakistan on former tributary would not be adversely affected. So what this means is that if Pakistan had an existing hydroelectric use on the river, Pakistan could claim that India's project is illegal. But since India conceived the idea first, India started the work first, the Court of Arbitration declared that India is in the right to do it. And also it is a inter-basin transfer of water between to the Jhelum Valley. So in that case, what about the environmental flows for the rest of the channel below the dam? So this is where the Court of Arbitration actually said that release 9 cumecs at all times after considerable discussion. So this was what the verdict was on KHEP after Pakistan raised a number of objections. Most of them were rejected, and India actually reduced the height of the dam and ended up with the project. And in 2018, our Prime Minister actually inaugurated the project. Another important contention that Pakistan had about the dam was the drawdown flushing to release the sediments. So sediment flushing is a very important problem because as I mentioned before, Himalayas are a young mountain, and in the Salal project that was constructed before Kishanganga, in 2 seasons, the dam got filled. So this means that it means a huge loss of money and waste of time and everything. So in Baglihar Dam, which was constructed before, which was also referred to a neutral expert in the second stage of the conflict resolution, Baglihar Dam was referred. So there Pakistan had said the same thing, and then their drawdown flushing was agreed upon. But in KHEP, this the Court of Arbitration actually rejected drawdown flushing because Pakistan considers it as a key security issue. So if Pakistan, if India had this drawdown flushing, what is drawdown flushing? Drawdown flushing is this orifice spillway on the dam, which is below the dead storage level, so that it could flush the sediments to make the plant work properly. So Pakistan thinks that if India has this particular feature in its dam, it can manipulate the water to flood or to starve the downstream areas of water. So, so that's why the Court of Arbitration also read the treaty similarly and actually supported Pakistan in this particular claim. So we have a lot, but the neutral expert who had referred to the Baglihar case actually said the drawdown flushing was is okay because he considered the climate change issues and other factors to say that yeah, this is this particular feature is important in that area. So here, in conclusion, we have a lot of confusion regarding the interpretation of the treaty, the use of technology, and various other policy issues which needs to be addressed. Which Indus Water Treaty is not actually it's not actually being able to do at the moment. So we need we need a transboundary water cooperation wherein we have a treaty which is equitable. We need environmental factors to be included. We need it to be sustainable. We need it to be technologically flexible. and we need it to be process-based. So our Indus Water Treaty is a very static instrument which hasn't changed in the past since its conception in 1960. So such a static instrument is not particularly desirable in our case, where various issues such as climate change, changing diplomatic relations are considered. So we need a process-based formulation. We have a lot of international laws and treaties which can help us do that. We have Vienna Convention of 1961, which governs the diplomatic relations, how the diplomatic relations should be conducted in terms of various natural resources. And then we have Helsinki rules, where groundwater and surface water, how in conjunction they should be governed in transboundary issues. And then finally we have the Berlin rules, wherein other than the rights of the riparian countries, we have obligations of the riparian countries, how to protect the water, how the protection of water is a responsibility of all the riparian countries. So the Indus Water Treaty actually doesn't have a lot of these concepts yet, because our understanding has also evolved considerably. So the recommendations are the new treaty, the amendments, or if the treaty is rewritten, how it needs to have the sustainability, the environmental needs, and climate change factors to be addressed. China, a huge, one of the major riparian countries, which hasn't actually done much right now, but China is actually partnered with Pakistan to build the hydropower dams, which we are talking about in Pakistan. So China is silently, indirectly influencing our basin. So we need to consider how to combat Chinese influences properly, and how to make sure that our relationship with Pakistan doesn't deteriorate. We need to involve technology innovations. So when we make sure that technological innovations are considered, instead of limiting the technology, like how the Indus Water Treaty is doing. Indus Water Treaty specifically says that only run-of-the-river projects are to be allowed. So instead of that, we can have operational restrictions, wherein if Pakistan demonstrates damage after a particular power plant is hydropower plant is operated, then we can take particular steps to reduce its operation or change its design. So and then we also have how when the treaty is considered, how in the already existing structures, where are we going to put them, how the cumulative effect is going to be. So the cumulative impact assessment is not considered in the treaty. So we need to consider that as well. And in the bottom right corner, you can see a diagram wherein we can see the types of transboundary rivers. So in this particular paper by Gleditch, you can see that there are 4 categorizations, wherein the first 2 are cross-border rivers, and the second is a border river which runs very close to the border, and the third is a hybrid. So when we consider this particular differentiation of the rivers, our treaty lacks in this aspect, wherein we have one rule applies to all concept. So we can make our treaty a little bit more river specific. We have many tributaries, so we can have, instead of classifying it as western and eastern rivers, we can have river specific provisions in the treaty. And then finally, to do all of that, the marine spatial planning tools, as discussed earlier, could actually provide a very good basis to start off the conversation, to start off the negotiation for a more comprehensive treaty. So the policy interventions that we can plan are a sound balance between socio-political goals and scientific understandings, and address the food security issues, we can take steps to improve India-Pakistan relations by scientific and technological collaborations and transactions. And then we can have we also need policies wherein we combat China's economic and political interference, which is happening directly and indirectly. And overall, we need to strategize India as a regional leader to to make sure our food security and water security issues are combated, and our economic power also increases. And then finally, we need digital interventions for which policy interventions are a must. And then marine spatial planning also needs to become an important part of the policy considerations. So the further work which is required in the Indus Basin future is to actually first of all understand the shortcomings more clearly about what the socio-political, socio-economic, socio-cultural and technological and environmental shortcomings are. Then digitization and strategic security requirements of the basin. So this needs to be very site specific, and how the water flow and water quality monitoring is done. So these are huge gaps that are present, and these they need work. And how we control how we manage flood and sediment. And then what are we doing to make the Indus Basin climate change resilient? And how are we managing water demand, groundwater and surface water? And how is the stakeholder mobilization happening? So recently, India actually sent a notice to Pakistan to actually inviting them to discuss the treaty again, to treaty provisions. But Pakistan hasn't been responding positively yet. So how the stakeholders are going to mobilize. So that is a very important aspect of the policy work, and how the capacity is going to be built regarding the same. So the MSP tool, how the marine spatial planning tools can be used for transboundary water cooperation. So the vision is that the political process that is happening needs to become a public process, wherein all the tools and everything becomes operational. And the tools needs to be ecosystem based, area based. It needs to be integrated, adaptive, strategic and participatory. So the planning needs to be, it has multiple objectives. It needs to be spatially focused, site specific, and it needs to have an integrated approach. So the way ahead with underwater domain awareness, as the underwater domain awareness framework says, first we need to sense the gaps and then analyze, sense and then analyze the data and everything. And then we need to make regulation frameworks to make to make sure that we are water quality management, flood and sediment management, climate resilience, farm practices and income management, food and energy security, acknowledging the ecosystem services. So if India is letting go of water to Pakistan, the western rivers, in its pristine form, Pakistan actually is indebted to India to do that. So this comes under the ecosystem services factor. So do we have transactions to do that? And if we are polluting, so do we have, or if Pakistan is polluting the water which is going into the sea, or if so, do we have transactions and penalties to make sure that doesn't happen? So, and we have to keep up with the technological innovations that are happening and make sure that the treaty doesn't impose severe restrictions on technology, because those restrictions has what made India and Kashmir's issue even more strangled because of the technological restrictions. And then we have marine spatial planning, wherein, as discussed before by presentations by other fellows, they have the potential to make sure that the Indus Basin is properly governed and scientifically governed. So I will end my presentation with this following quote. Allocating water in transboundary basins is not a new practice. The looming water crisis accelerated social, economic, and technological developments, and climate variability and change call for new flexible approaches in allocation in order to future-proof water management. Thank you.
Thank you, Catherine. I think it's very timely. On 24th January, India has given notice to Pakistan, and the relevant issues have been raised by you. Sediment management is a very important aspect. Digital transformation is a very important aspect. Environment and water quality as a strategic security challenge is something which needs to be recognized. And going forward, we have to create those instruments to make sure that we have, like, even the pandemic has been a great wake-up call where a lot can happen. And particularly when we talk about transboundary river water being used for domestic purposes, there's a huge strategic security concern. So do we have the wherewithal to really keep track of what is happening? Do we have the instruments to monitor whether we are safe or not is a question that we need to ask ourselves. And also, there are so many other dimensions which you highlighted, Catherine. When within the federal structure between the states, the gaps have increased. You can see today we have not been using the entire allocation that has been given to us. And it's not so easy to say how will you... Now, what are the larger water consuming instruments that you have? Industries, is it easy to set up industries if you do not have the power for it? So there are a lot of interconnected things that we need to understand. And a lot more studies are required. Broadly, few things are now understood, but this is an ongoing process. MRC is very seriously working on this project. We are also giving inputs to the authorities on certain way aheads. And is there any questions on this?
So the question reads, India issues notice to Pakistan to amend the 1960 Indus Water Treaty. So Chetan Kale asks why. So as I mentioned in my entire presentation, there are a lot of multiple interpretation of the treaty. The treaty doesn't have enough bandwidth to actually incorporate the technological innovations. So, and in the recent Kishan Ganga issue, Pakistan again raised objection in 2018, saying that it still doesn't agree with the Court of Arbitration verdict. And it says that it needs a neutral expert now. So India said that we still need a COA. So there's this huge confusion regarding how Indus Basin is going to be managed. Climate change is not at all considered in the treaty. And it is one of the hot issues which needs to be considered in any basin. So, and even groundwater is not considered. So we have a transboundary groundwater which we share, which is not considered. So there are a lot of aspects which are not there in the present treaty. And India is right to say that it needs to amend in a more peaceful way, in a more collaborative way. If Pakistan, looking at the fact that Pakistan's most of the economy depends on Indus water, India and Pakistan needs to come to a common ground to actually decide what is best for both of them. So yes, sir, that's my answer.
Thank you, Catherine. I think you've covered most of it. So thank you very much. This is a topic we can discuss a lot. I think I will not indulge into that now because it is an issue which has been raised by the government and we don't want to comment too much on what the intricate issues are. But I'll be happy to answer some questions in a private conversation. But thank you very much, Catherine. You've done a great job in covering various aspects. And when you touch upon policy, I hope the participants appreciate there are so many dimensions to be covered and it requires a very, very multidisciplinary approach to the whole thing. And Catherine comes from a very fantastic background, and I think she's quite appropriate to kind of deal with a topic like this. She is from St. Stephen's and then Ashoka University and then Shiv Nadar, and has been working on this for more than a year now. And now we are getting into a little more serious work of how to bring all aspects of intervention on the ground. And the digital transformation, I think, will become a very, very important aspect. And thank you, Catherine. It was a good presentation. So we will end the day today. Thank you very much. We have enjoyed delivering, and you can see the diverse nature of projects and how they are interconnected. And there are many more projects, but I think there is not enough time. But I would encourage you to visit our MRC website. You will get a spectrum of, there is a similar project on the Brahmaputra as well, because there are issues there also. And but we don't have much time to present each and every, but we'll be happy to interact with you. Please go on our website and see the different projects that we are doing. Even we have a project on impact of underwater noise on the diving, because now with so much of activities going on, a lot of diving activities will be required, both recreational and occupational. But the entire, pollution, I mean, we have taken in that project, we have taken the specific aspect of underwater noise, how it will affect, and what should be the regulatory framework looking at it, and even a technology tool to manage diving. Suppose you and me decide today that we want to go and dive in a particular place. Don't you think we need a tool to make sure how safe it is to dive in a particular area? And even from a regulatory perspective, if permissions have to be given, don't you think there is a tool required which can, from a public health and safety perspective, what should be? So we have developed a tool on that as well. And so we keep finding new ideas and keep working without worrying too much about whether we get a project on that or not. We have been working on the fundamental framework of the UDA. We have done a lot of projects. If you look at the number of research notes that we have, you will get a lot of inputs. Young students can look at ideas. One is for their own degree requirement where they need to do projects. You can join us, but also startup enthusiasts can also come to us and look at certain ideas, and we'll be happy to help. Thank you so much. We'll end day 2. Happy to continue the conversation tomorrow. Thank you.